Hi everyone, and welcome to Coding with Tom. In this course, we're going to cover everything you need to develop a full stack web application using Blazor Server. And we're going to use some best practices as well. So not only are we going to go over how Blazor Server functions in ASP.NET 7, but we're going to include other things like using Entity Framework to connect to a database, using the ASP.NET identity to manage user logins. But we're going to do the repository pattern on top of our Entity Framework as a best practice. And we're going to be using some user interface components to show how you can do more advanced user interface, especially when it pertains to viewing and editing data. And then at the end, we'll do a little bit of unit testing. Now, I want to note that I'm not covering WebAssembly or REST APIs yet. I plan to do that after .NET 8 is released, as there's some major changes coming, and I will redo the course with those additional options. What's happening is the new Blazor project is not going to have Blazor Server and Blazor WebAssembly as two separate projects. You're going to be able to mix and match the functionality when you want to, and to accommodate that, they're updating the identity as well and including templates in Blazor for identity, which they didn't do yet. Right now, they only have them in ASP.NET Core. So a lot of that's going to be updated, and I'll go into more of that since the new .NET 8 is planned to be released in November of 2023. So who's this course for? This is for anyone with an intermediate or even expert programmers who want to learn Microsoft Blazor and how to develop full stack web apps using that. You should be comfortable in programming in C#. You should have a basic knowledge of databases and SQL, and you should have some basic HTML knowledge. One nice thing about Blazor is a lot of the need to know JavaScript is not an issue, so you'll see how that works in Blazor. So HTML knowledge is all that's really necessary, although JavaScript does help. So the first thing I want to do is show you a demo of the application we'll be developing in this course. The application we'll be developing is an invoice management system. So let me give you a demo of how it works. You can't do anything until you log in because our invoices are going to be stored for each customer, and each customer will have different invoices. So if you try to go to any of the pages, it'll tell you to log in. So we're going to register for an account. So let me register with a dummy email. And then I'll click here to confirm your account because we didn't configure email sending to send a confirmation email. So I'll close that and then log in. Okay, now that we're logged in, we'll see that we have a page that shows the invoices that we have, and we don't have any to begin with. So what we're going to do is add some invoices. But you'll notice that we have invoices for customers, and we also have this idea of invoice terms. So a customer is just the name of the customer we're going to invoice, and the invoice terms are just when an invoice is due, like is it due in 30 days, 60 days, or 90 days. Now we can set up our customers and our invoice terms over here on the customer and invoice terms pages. So if I go over to customer, you can see I have by default a my first customer, just so there's no, there has to be some data in, so I have it automatically create my first customer, which we could rename by editing it and do that, for example. I could also add another customer and another customer. However customers you'd like to add. And the same goes for invoice terms. It defaults to having net 30, 60, and 90. And I could add, perhaps, if I wanted to, like net 120 and net 45 if I want, or any other terms that I'd like to define. So now that I have that set up, I'll go back to home and I'll add an invoice. So I can pick the customer I'd like to add an invoice for, and I'll add it for Microsoft. And it sets up some values by default for you that you can change. So I can go in and actually change the customer if I pick the wrong customer. I can change the terms, so I'll make that net 30. And I'll say this is an invoice for groceries. And I'll assume they haven't paid anything yet, and we're not giving them a credit. But I'll put a tax rate of 5% on, and I'll save my changes. So that will save all of the changes up here. Now, this invoice really has nothing in it yet, so I'm going to add some line items to the invoice. So let me click this. And I'm going to add apples. So we're going to buy for 69 cents each, 12 apples. And you'll see the total automatically updates. I'll add another for cucumbers. And we're going to buy for $1.22 or whatever, 6 of them. And we're going to also buy some ice cream. And we're going to buy at $3.99. We're going to buy 2 of these. So you can see that it gives you a total, the tax, the total with tax, and how much is still due on the invoice. So if I go back to home, you'll see that that invoice is there. Now I can add another invoice, and I'll just add one quick. I won't put any line items for now. I'll go back. You can see they show up in the list. I wanted to do that because I wanted to show you how we're going to be using this interactive data grid component from Radzen, which allows us to do some interesting functionality on our data grid, like sorting. So I could sort by description, create date, customer name, invoice terms, the total, how much is due. In this case, this one still has money owed, so if I actually go and edit it, I could change the fact that they paid, let's say, $10, and save that, and go back home, and you'll see now they only owe $14.76. So, and we also have this filtering capability, so I can filter by date. This will come up and let me pick a date range or other date criteria. The customer name, I could check off just customers I want to see, like Microsoft, for example. And invoice terms, I could just pick whoever has a net 30 invoice. I could sort by what's due. So this grid gives us a lot of functionality, and I'll be showing you how to do that. So, and let's say I also want to delete an invoice. I can go into here and go down to delete, and it'll pop up a screen saying, are you sure? And if I hit yes, it'll delete it and go back to the invoices page. So this covers a lot of functionality that you would need in a typical CRUD type system where you create, read, update, and delete data. So I hope you find this course useful, and hopefully it will help you get started in developing your own applications in Blazor Server. Before I jump in to show you how we get started, I'd like to remind you to please like this video and subscribe to the channel if you find this course useful. Let's start off by creating a new project. So let me click Create New Project. And then in the project templates, I'm going to look for Blazor Server app, and that is in C# and Blazor categories. I'm going to call this Blazor Invoice app. Now I'm going to choose .NET 7, which is the latest release framework as of making this video. For authentication type, I'm going to include individual accounts. I'm not going to enable Docker, and I'm not going to use top-level statements. I'll hit Create. Okay, before I actually go through and explain the different folders and files that are in the project, let me do a demonstration of this project that comes out of the box with the template. So to run it, you go up here to the top and you click the green arrow next to HTTPS, which will start running the program in debug mode. It should start up the ASP.NET web server and load a web browser and connect it to the web server. So this demo consists of 3 pages, and also has access to the Microsoft Identity system, which is an ASP.NET system, which allows you to register users and log into the site. So we'll try that in a minute. But first, let me show you these 3 pages. So the first page is essentially just a welcome screen, no interactive components except links to other pages and a link to this survey, which is not actually on this site. It's hosted on the internet. Now, if I click over to Counter, this is a demonstration of how Blazor does interactive components, which I'll explain more. And here is the fetch data, which is another example of how data is retrieved from a service. In this case, a temperature service that is running alongside the web server. And we can also register a user for this website. So let me click register. And to do this, you just put in any email address. Doesn't matter if it's accurate. And a password. And I'll click register. Now, the first thing that happens is you get this error. The reason you get this error is because there is a database that is supposed to be set up alongside this application. The database contains all of the users that are registered for the site and any roles that they're in and other information related to the Microsoft Identity platform. And I'll show you those tables later. But the way Blazor handles the database is it uses the Entity Framework system. Now, Entity Framework creates the databases from the source code. At least that's how it's configured in this project. And the way it does that is there are objects that define the different columns that would be in the database. So there are different classes that map to different tables in the database. So the first time you run the program, it has to actually create those tables in the database. Now, the database that the main template project uses is a SQL local DB database. So this is just a file that is saved alongside the project. And the SQL local DB engine will use that file. So in order to seed this file with the tables, you have to click Apply Migration. So you have to do this the first time. And we're going to be doing more of this later when we add our own tables to the project. But for now, just to get going, click Apply Migrations. And then it tells you to refresh the page. So if we go up here to the top and hit refresh, what it does is it continued to register. But this is the point where if you were to fully deploy this solution, you would want to configure it to actually have an email sender. The email sender is just another service that will actually send emails to people as they register. The reason you do this is because it would actually send an email to the email that the user provided when they registered with a secure link, or a unique link, I should say, to click back and authenticate that that email is actually legitimate. That's turned off by default, but that's something you can implement if you'd like to, but that's outside the scope of this tutorial. But for now, just you can click here to confirm your account. And what that does is it emulates the process of having opened up the email and clicking the link, which would bring it back to this website, which then confirms the email. So once this is done, you can actually log in with the user you just created. So if I click login and I log in, it will work. So it actually knows that I'm logged in. It has a little section up here that mentions the username, which in this case is the email address. And then the login button turned to log out. So now, other than being logged into the site, the functionality doesn't change. The counter page and the fetch data still do the same thing. There's pages that are accessible whether or not you're logged in. So we're going to actually go into more detail in that later when I get to my invoice example. And then you'll see how you can control access to either the whole site or certain pages based on whether the user's logged in or not. So now that you see what this template project provides, let's go back to the source code and I'll give you a tour of the different files so that you can see how it's implemented. Let's get started by closing the web app and going back to the code. Now everything begins with the program.cs file, so let's take a look at that first. What this is the main program that runs when your web server starts up. And the first line of code is this web application.create builder. What this does is create a builder object that is used to set up all the configuration options, initialize any services, etc. for running your web server. So the first thing it does is add this DB context. And what it really does first is go into the configuration file and get a connection string which shows it how to connect to your database. So I'm going to actually put that on another line. And it either finds the setting for the connection string in the database, or it throws an exception that the connection is not found in the configuration file. So what I'm going to do is actually open up the configuration file that it uses, which is appsettings.json. So that's this other file here in the root of the project. So if I open that up, you'll see there's not a lot in here. There's a connection string section, which has a default connection, which tells it to use local DB and creates a unique file name for the database. So it's based on your project name, and it has a GUID after it. So this you would replace with a database that you would host your application with. You typically wouldn't use local DB when you deploy this to the cloud or on a server. You would probably use an actual SQL Server instance, so you would find the connection string for that and place that in here. Now there's also a logging section which configures how the logging is set up for this application, and allowed hosts just tells it who's allowed to connect to the page. So the star by default means everyone can connect. So these are the these are the configuration options that are set up for this app to begin with. Now you can add other things to it, and we will. But let me go back to program.cs. So this first line is just getting that default connection string out of the file. Then there's a line here called add DB context, which actually creates a database context based on the SQL connection string from the file. Now with DB context is just the mechanism to connect to the database. So it initializes the services and libraries required to connect to whatever database you're using and has that available in the background. Now there's also this option to add database developer page exception filter, which allows you to show more detailed bug information that in the responses if necessary. This is something you could probably remove in production. The next thing is this add default identity, which adds the Microsoft identity system to your application. And it's based on certain options that are provided. And this object right here, which is important, this is the object that is representing a user. Now this is the built-in object in the library, but you could create your own user object and extend it to include additional fields for your user. But by default, this is going to be a object that has all the information that's required by Microsoft's identity system, and it'll map directly to a table in the database. So we're going to see how that happens later too. And because of that, it needs to know, since the database is involved, what database you're using. So when we add identity, it's actually adding the entity framework store along with it, because it's going to store its identity tables in whatever store you've created. And that's why application DB context is passed again into this. So the application DB context object is something we're going to look at. That's sort of your main object that stores every object that has to do with whatever tables and databases you're using in the system. The next line is to add Razor Pages, which is a feature of ASP.NET Core that we're using. And in addition, we're using server-side Blazor. Server-side Blazor is an add-on to ASP.NET Core. So you can use the Razor Pages and Blazor in the same project. And actually, all of the identity pages that are provided are implemented as Razor Pages. So if you want to customize them, you have to use Razor for that, not Blazor, unless you implement your own Blazor Pages from scratch, which you can do. Future versions of the framework are going to include Blazor versions of the page right out of the box. but we'll get into that later. Then the next service we're adding is what's called a kind of a generic service. There's three kinds of services you can add: scope services, transient services, and singleton services. I'll explain the difference between them later, but the scope service basically has a lifespan of the connection from a particular client to your application. And there's this thing called the authentication state provider, which is another object that this template includes by default, which we're going to make use of. And what it does is it tracks the current logged in user so we know who is logged in at any given time. And that's something they've implemented to be compatible with the server-side Blazor. So we'll be using that. And then there's another service here that's added just for this template called the weather forecast service. And this is just a custom service for this demo that provides current weather information. It's actually generated randomly, so it's not accurate, but still, it's to show you how to use the service. And that's a singleton, which means there's one instance of this object that's accessed by every single connection to your web server. So it's shared. So any variables on that object are going to be shared amongst everybody who connects to your web server, at least on this instance of the server. So if you have one server running your web application, there'll be one weather forecast service. Whereas the scoped will create an object every time a new person connects to it, a different client, a different machine. Then transient is the third type, and what that does is that lives only for the length of the particular connection. So even if you have a client, let's say a user's logged in and they connect to your website like over and over again, transient will create a new object every time they connect to the server or make a request. But scoped will stay alive for the entire session that the user's logged in. So this is sort of in order of, if I'm going to say in order of lifespan, the transient objects and services live the shortest amount of time. Scoped are next probably, because they live for an entire session of a logged in user. And singleton will live for just the entire application. So that lives a long time. So there's more details regarding the lifespan of these services and when to use them and when not to use them. But for now, we'll just leave it at that. So once we've added all these configuration things, we tell the builder to build. So what that does is it creates an app object, web application object. So we can use that to actually host this application. So there's a couple options we provide on it. First of all, if it's in the development mode, so if you're running this in debug, we do this migrations endpoint option. And otherwise, if it's not, then we have these options here. In production, you want to use an exception handler, which is what this does, which anytime an exception occurs in your application, it'll redirect into an error page where you can handle the exception, display it in a way that won't scare your user off, or at least provide them information they need to continue. And then HSTS is a strict security setting that you don't want to have on for development, so it's enabled in production. So that's what that is. Now, there's other options for the app before you actually run it, which is the last line here on 57. Using HTTPS redirection lets you do redirecting to HTTPS links. Like if someone tries to hit your site using regular HTTP, it'll redirect them automatically to the secure version. Static files allows you to serve regular files from your web server, like if you hosted a text file or just a static HTML file. Routing is a whole nother area we're going to look at, which handles how to route URLs, and there's ways to configure that we're going to look at. Authorization is the whole it's not the identity system, but it's the authentication system. So you can add rules to what resources are accessible to different users and whether they're authorized or not. Map controllers, what that does is if you have any controllers in your application, and that's something from ASP.NET Core, you might have API endpoints or other pages that you want to have mapped, and that handles that. We're not going to do that in the beginning of this tutorial. Then map Blazor Hub is just a Blazor feature option. And this is the fallback page where this is where it will go if there's no request. So it's like your index page. It's like the default page. If it doesn't match something, it'll go here. And then when that's done, you do app.run, and then the entire system is up and running and ready to serve its first web page. Okay, so the next file I want to look at is imports.razor. This is a file that's included in all of your Blazor pages. And really what it is just a bunch of using statements. So any libraries that you're going to be using across all of your Blazor pages, it's good to put them in here so you don't have to actually put a using in each of the files individually. This is shared, so it makes it a lot easier to do that. The next file I want to look at is app.razor, the last file in the root. Now this is the first Blazor component page. So let me try to explain this. First of all, the entire thing is contained in what's called a cascading authentication state object. So that is this tag that begins and ends here. So that's probably something I should explain. These are Blazor components. A Blazor component is mapped in these Razor pages to actual tags with custom names. So there is a cascading authentication state Blazor object. It's in the Microsoft ASP.NET Core Components authorization library. And what that does is it will make sure that the authentication state of the user is included in every single page. So that involves any cookies that are involved in designating who's logged in at any given time. And that will make sure that the headers of the HTML and HTTP, actually the HTTP headers, are set properly and are accessible to the page that you're on. Then within that, there's a router. So the router object is the main Blazor routing mechanism. And what happens is it has the ability to find or not find different pages. So each page that you create is going to have a route to it that we specify at the top of the page. So this knows about that. And what it does is there's this found area and a not found area. So if it's a page that exists in our website, and in our template website we had 3. We had that index page, we had a counter page, and a weather page. If it finds it, then what it does is it will show the page with the authorization included. Again, this is because we have authorization enabled for this Blazor project. If you didn't, you wouldn't be using these authorization controls. And there's a default layout. So there's this main layout that we're going to look at, which is how the page is laid out. It's like a framework for how you organize the components on the page. So that's another thing we're going to look at. And if we're not found, there's a different layout. So in this case, it's the same layout, but it just shows a paragraph saying there's nothing at this address. So this is kind of how errors are displayed for pages that are not found. So if you have a link to a page that doesn't exist in your project, this will take care of that. For our purposes, we're not going to need to modify this, so we can just leave this the way it is. Now, if we go to shared, the shared folder, we're going to see some of these files we just mentioned. So these shared files are just components that are shared by all of the pages on our site. So again, we had those 3 pages, but we're going to have components that are shared. So the first one we mentioned is this main layout. The main layout will show how pages are laid out. So if I go to main layout, this is a type of component called a layout component. So it inherits everything from that. And it has a page title. So this is another component that actually will include in the header of the HTML this, so that the title shows up in your web browsers at the top of the bar in the URL. Or the tab. So the tab you're on will have the name of your application. Now this div is just HTML code now with Blazor components embedded into it. So a div is just standard HTML. And a class is just the CSS that goes along with it. And these classes are from the Bootstrap CSS library, which is the default CSS that's used in these Blazor templates. So right here we have another Blazor component. It's called nav menu. So that was the menu on the left side of the screen that we saw that had links to the counter, the home, and the weather forecast, fetch data. And so that's another object we'll take a look at. But this is it just instantiated right here. So you can tell it's a Blazor component and not HTML because it has this slightly different color. So that's going to be embedded in there, and that's the sidebar. So in the Bootstrap sidebar, which is that left side of the page, is going to be a navigation menu. Now in the main section of the page, which is to the right, there's going to be a top section, which is this div, which is that header across the top. And that has a link to the About page at Microsoft, but before that has yet another Blazor component. So this login display is the component that's responsible for showing the username if they're logged in, and if they're not logged in, the register button, and also the sign in and sign out buttons. So we'll take a look at that in a second. And then under that is this area here, which they're using the article tag for, and including this @ body. So this is the first time you're seeing this @ sign, but I'll explain that further in the counter page so you understand how that works. But you're seeing it here too in inherits. But anytime you see @ that means you're switching from HTML to C#. So the inherits up here is telling you that this C# object that represents this main layout is inheriting from this base object. So that's C#, which in C# normally you would just use the colon with the name of the class after it. So this does that for you. Now the @ body just means include the variable body here. So the entire body of the page that's being rendered will be replaced right here. So this body will be replaced with the body of the page. So when we go to the counter page, that'll be shown here. The fetch data page will be shown here, but notice the rest is still here. The nav menu and the login display are still here. So those still show up on the top of the screen and on the side. So the only portion of the page that changes when you go from page to page is this body area. So that's why you use these different layouts. So this particular layout includes having the navigation menu and the top bar always present on the page. We're going to change this for our application, use a different kind of layout. But for now, that's what this means. So let's look at these subcategory objects here. We have this nav menu and login display. So let me go over to nav menu first. That's over here. And this is just another set of divs using the Bootstrap CSS. And what it has at the top here is a navigation bar toggler. So that's that little hamburger menu at the top that will open and close the menu. And down here we have basically the menu itself with the CSS, which I'm not going to go into a lot of detail, but the CSS for Bootstrap. And each link to a different object, though, is a Blazor object. So you can see this Blazor object tag, again, slightly different color. It has a class. There's a match property to that Blazor object. And that will match all URLs. This match has to do with whether this link is active, and what that just means is highlighted. So if you have navlinkmatch.all, if you're actually on the root of the website, this link will be highlighted in the menu. So we'll show you like where you are currently. If you leave that off, then we have, like for example, in this next nav link, it's going to be looking for counter. So if you're at /counter on your page, then this link is going to be highlighted. And this link will be highlighted when it's /fetchData. So these nav links also create the links. So these links are clickable links that take you to the different pages. And let me just run the program real quick to remind you of what that looks like. So to reiterate, the main layout basically includes the fact that there's this nav bar over here. Then at the top, there's these register, login, and about, and then the body is everything in this white area. So that's the body. But notice how home is highlighted right now because we're at the root of the page. So you can see there's, that's the slash, implied slash there. If we click counter, you'll see it goes to /counter. So that's a different page. Now, since we're at /counter, it highlights the navigation menu item for /counter. If I click fetch data, again, this is /fetch data, so that's the one that'll be highlighted in the menu. So every time we click from page to page, the appropriate link is highlighted. And these links are clickable, so it's taking us to those different URLs. And we're going to see how each page works. So that's it for the nav menu. Now this survey prompt is just an object that the main page uses to connect to Microsoft for a survey, so I'm not going to go into that. But you know what we'll do is I'll actually remove it from the front page. So let me start to talk about the actual pages. And they are in the pages folder, so let's click that. Now you'll see there are a couple CS/HTML files and a couple Razor files. Now the CS/HTML files are what are called Razor Pages. This is a feature that's built into ASP.NET Core. This is not a Blazor feature. This is part of the ASP.NET Core functionality. If you look into how to code in ASP.NET Core without Blazor, you'll be using Razor Pages. And Razor Pages are basically still a combination of HTML and components, but there's not this interactivity element. You have to, your page can post or do a GET request or do a POST request and then return a response, but there isn't this live two-way interaction that Blazor provides. So the host page, though, is the kind of the main page for the whole Blazor Server app. It's the root page that's loaded. So you can tell it's the root page because, well, first of all, it's marked as /. So this first directive at the top tells it what the URL is for this page, and this is for the / page, which is the root of your website. It includes some libraries, tag helpers, etc. I'm not going to go into too much detail in this because this is ASP.NET Core. But what's important is this page loads and has like your HTML tag. So that's, obviously this is the main page and has the head with the body. What happens here is this is where the Blazor Server app is actually included in your application. So this JavaScript here is responsible for kicking off the SignalR connection to your server. Your initial page is rendered out here inside the body with this server pre-rendered mode. So it takes your entire application and renders the first page with the /URL and has obviously some options here. So there's the div for the Blazor errors, depending on whether you're in development or production, and you can reload the whole page, etc. So this is not something you change. This is the Blazor Server framework page that's built on top of ASP.NET Core. So this is a page you're not going to want to modify unless you want to change your application's CSS. So right now you can see it's using Bootstrap. So if you need to include any other JavaScript libraries or anything like that, then this would be the place to do it. But for now, we're going to stick with Bootstrap and not change this page. The other CS/HTML file page is similar, but it happens when there's an error. And if there's an error, we don't need to kick in the whole Blazor system. It just shows the error on a page, and it still includes Bootstrap, but it doesn't need to instantiate Blazor because at that point, it's just showing an error. And it's using this model. So in these pages, this happens to have a CS code behind page. When this, again, this is a ASP.NET Core functionality, so I don't want to spend a lot of time on this. That would be a separate tutorial. The focus of this is Blazor. So this is just here, and you can customize it if you need to, but it's here to get the Blazor system up and running. Now, the other three are the 3 pages I mentioned. So we have the index page, the fetch data page, and the counter page. First one we'll take a look at is the index page, because that's the simplest page. So this is the basic layout of a Blazor page. This is sort of a minimal version of a page. You have the top, this @page directive, which again, when you see the now we're talking Blazor and potentially C# code. But this @page thing up here tells it what page this is. So if you go to /, that routing element that I showed you before, which was in the app.razor back here, will know that the /page is this index file. So because this index file defined its page as /, this router will know to go there. But it'll also know to apply the main layout to it. So you don't lose the menu, you don't lose the top bar. It's going to take this index.razor page, render it out, but include it inside this main layout that we have here in main layout.razor. So you can see this page only has that page content from that white area in the center, but it has the URL /. So this is in charge of the /page. And what it does first is it changes the page title at the top. So I'm going to go ahead and modify that. My page, hello world. And again, this is HTML, just a header tag, whereas page title is a Blazor and welcome to your new app. The survey prompt includes that survey prompt Blazor component, which is living in this other Razor file. So you can include Blazor components within Blazor components that you code. So this is the Blazor component we didn't code. It's part of the library. But this is actually coded here in this survey prompt. So you can include the survey prompt object, and notice it even has its own custom property here. So if you were actually to go look at this survey prompt object, it will render out this div in HTML. And the first thing it does is it actually includes the title variable. Now, a Blazor component, this survey prompt.razor Blazor component, is a combination of HTML markup and code. And it's either embedded in the HTML directly, which is what this sign up here is. This @title means put the value of the title variable in this location of the HTML. Down here in the code section are definitions of code for this object. So notice that this is just living here, public string title get and set. This is a property that belongs to the survey prompt class. We put this decoration here of parameter, this attribute, which lets us set this title via the HTML tag for the survey prompt. And that was utilized back in the index page. So if I go back to index, you'll see this title here is an attribute now on this HTML tag. I could add another one. Like if I wanted my survey prompt to have something else, like another message, I could go back here. I can come here and add another variable to this class, and I will put the parameter option on it, make it a string, and I will call it, maybe I'll call it like message, because we want to put a little more content here. So I'm going to do that. But then up here on the actual survey, we have the title, and then I'm going to actually put a paragraph under this and actually include the message. So it's going to show my title and my message, assuming I set one, because by default there is none. So that's another thing. But let me go back to index, and I've only set title, so let me set a message. And I'll say, hopefully you will enjoy this. So now we have a title and a message attribute on this Blazor component, which we've defined here in survey prompt. So when I run this, now let me step through this again. When I run this, the page that first loads on any web page is the root page. So this page is going to load. It's going to see that this index.razor file defines what the first page looks like. So that's going to be interpreted by the router here in app.razor to be a page that needs to be displayed, but needs to be displayed with this main layout. So it's going to render out that whole layout with the menu, and then render out the index. Now when index renders out, it's going to include the survey prompt object. So the survey prompt object it's going to go to this file, survey prompt razor, and render out the survey prompt. It's going to include these title and message variables that are embedded here. And notice when I click it, it like highlights the one down below. So it's literally referring directly to the same variable that's defined here as a member of the class. Again, survey prompt is a class. And the code for the class is defined in this code section here that begins with @code, open and close curly brace. And you can tell because it's purple. So this purple color delineates the fact that you're dealing with C#. So as I highlight here, this is C#, this is C#, and this is C#. So let me give this a run. And we should see on the main page our additional message, which we do. So this title is here. Under it is a paragraph. Hopefully you will enjoy this. And then there's a link to the survey. So the changes we made do work. And in fact, look up here, it says my page. So even changing that component to have my page worked. And that's back in index. So if I go back to index, that's this page title. So this page title object actually goes and sets the tab's title at the top. So that's what this index page is made up of. Just a simple page that has two Blazor components on it. The first one is a built-in one that sets the page at the top. And then the survey prompt, which is another file here in the shared files. That is a custom component for which we've passed in two parameters as HTML attributes. Okay, so far so good. Now this, however, doesn't really show you some of the magic of Blazor. What pages do really are these counter and fetch data pages, where they give you a little more interactivity. Because as of now, we really have just kind of had templates here. Like this index page is a template, which has a survey prompt, which is kind of like a template, even though it populates a couple variables here, like these two messages. It's still not interactive in a sense, because you're not clicking buttons and getting responses back. But now the counter page is fully interactive. It's pretty simple, but it's interactive. If I run it, I'll show you again what it does. The counter has a button, and every time I click it, the value goes up by 1. So back in the old days, this would have been coded by having a button, which would actually create an HTTP request back to the server, which would render out an entirely new page, including this whole layout, with the next number in the sequence. So there'd be this like flashing that would go on, like you click the page and then the whole page would have to refresh. Now that's not what happens in Blazor. When I click this button, it is not refreshing the whole page. When I click this button, it is taking this click action, and in the background, it's sending a request back to the web server saying, in this session, which is me connecting from this computer, have clicked the button. You have my session. You know what my current count is because you know which computer I'm connected from. You also know that when I click the button, it's supposed to increment this number. So the number is, the server on the back end is running the code that increments that value. When it increments, it also knows that this page needs to update, and particularly right in this location. This part of the page has to be refreshed to change to 24. So what it does is send back a message, again, all in the background. So there's no refreshing the page, you're not seeing this happen. It comes back via SignalR that you need to change this from whatever it is to the next number, and it provides the next number, and it provides where on the page it is. So that then is executed by the JavaScript and only changes the piece of the page that had to change. So there's no refresh, there's no flickering. It just changes this little piece of the page. And that's all handled through SignalR. So let's see in reality, now a lot of that's happening in the background. You don't have to worry about all those details to get started. So let's actually see what this code looks like. And it turns out it looks very simple. And it's very powerful. You don't have to handle any of that back and forth in the background communication because the Blazor Server framework's doing it for you, and as is the JavaScript running in the web browser that connects to SignalR. But let's close this. So let's look at the Counter.razor page. Here we go. Again, this is similar to the index page where we have a combination of C# and HTML code. Up here, we start with the Blazor code, the C# code that says we're going to have our URL be /counter for this. So anytime we go to /counter, it's the router that was back in app.razor is going to know to load this page, and it's going to load it into the body section of the main layout because the router knows there's a layout that we're using for all of our pages. Then this is going to run, and it's going to change the tab at the top to be counter. So I could change this to my counter if we want to see at the top what that does. Then there's a header tag, HTML, paragraph with a CSS role, which is just another bootstrap CSS to make it styled in a certain way. Current count. Now here we go, at current count. So in this, we have the placeholder. We have the area here where the C# variable current count will be placed. So no matter what the value of current count is, it will be displayed here in this HTML section right here. Under that, we have an HTML button. So this is an interactive component now. Buttons can be clicked. So this is something we can interact with. So to make it interact, we have to have an on-click property. Now notice also it begins with an @ So this is a property that the Blazor server is going to process. This is not displayed on the client. This is not sent out in HTML to the client. This is processed, and neither is this, by the way. Anything that's C# code runs on the server. So this current count is placed in by the server, which by the way starts at 0. So when you first connect to the page, the current count variable will be 0 because that's the default value. We can see set here right in this member variable here. So that's substituted here. On click knows if a click comes back via SignalR from this button on HTML, and it ties it together, it knows which button it is, to call this increment count method on the server. So this increment count is going to run on the server, and it's going to change this current count ++, which is going to make it go up by 1. Now notice there's nothing else here. There's no other code that says, okay, my count's gone up, tell the client to refresh the page and update this part of the page to have the current value of the count. No, not needed. Blazor handles all of that. This runs on the server, increment count, which therefore changes this variable. It knows this variable's changed, so it re-renders the HTML, and that change is part of it. So that change is sent back to the client via SignalR, and that portion of the page that changed will be updated automatically. So all of this infrastructure is built in for you to be able to run the C# code on the server and just send back updates to the HTML code to update what the user is seeing. So this is an important thing. On click here will call increment count. And I could change this. So let's say we want to go up by 2 each time instead of 1. So let me change that to +=2. And so let's see if the changes I made work. So let me run it. And I'll go back to counter. And every time I click now, it goes up by 2 because I made that change. So it's a round trip in the background to the server. Click, connects to server. Server knows the current value is 12, increases it to 14, sends back the portion of the page that changed, and refreshes just this section of the page. So that's what we see. And it handles it in a very streamlined manner without any flickering. Because this part of the page didn't change, so that stays still, and as well as this. That didn't change, so only this changed. Now I'm going to increase this. I'm going to do a little more proving to you that there is this C# code running. So what I'm going to do first is include a list of items that's going to be shown in the HTML based on the count itself. So right below the button, I'm going to include an HTML unordered list. That's what UL is. This is a bulleted list of items. Now I want the list of items to be items based on how many current counts there are. So when we start, it'll be 0. But it doesn't have to be 0. Let me actually start it at 2. I'm going to start the value at 2. And I'm going to change it so that it goes up by 1 each time again. Now, how do we create, what I want to do is I want to have a li for each one. So if this were 2, I want to have a list item, which would be like item 1 and item 2. But this has to be dynamic. This is not something, first of all, I need to do that. This is not something that you want it to be static. If I just put this here, we're just going to have these 2 items, 1 and 2. It's not going to change no matter what I do. And I'll even show you that. It's just pure HTML. Go to the counter to see my items, and I click it. Okay, it goes up, but it's not changing this. So to make it change, we have to use C# code. So the C# code runs on the server and can use logic and anything you can do in C#. So what I'm going to do, instead of displaying these as list items just statically put in here with HTML, I'm going to put a for loop in. So for, this is C#, int I equals 0, I less than current count, I++, open and close. Now, the Razor page here is really smart. It knows that we started a for statement here after the at. So as soon as it sees the at, it's like, okay, now we're in C# land. Now we're talking about code that's going to run on the server in this template. So for, and this is a standard for loop that's going to run up to, well, from 0 to less than the current count. So if the current count's 2, it'll run 2 times. Open curly brace. Now in here you see HTML again. So it knows to switch back to HTML and then back again to C#. So this is HTML that it's going to produce. You know, I don't have to print it out per se. I just have to include it here. So it knows that this is actually HTML. And the tag gives it away too. I mean, it knows by seeing that it's a tag that it's HTML. So it's going to loop. And right the way I have it now, it would just say item 1 over and over and over again. I want to actually have the value of I. So I can inject C# again by just using at again and put the I right there. So now this portion here goes back to C#. So what we have here is C# from the at over to here. Then it sees the tag. Boom, it's back to HTML. Boom, back to C#. Boom, back to HTML. And then back to C# again. So now what this should do is every time I increment the counter, it should show an additional item in the list below the button. So let me go to counter and see it did work to start. So it went 0, 1. As I click it, it keeps adding new ones. So every time I do this, there's a task that runs in the background, connects to the server, increases the number, refreshes the index component. And what that does is just change this part of the page to include the new list that has all of the items in it. And I can keep going forever, and it'll keep going down the page. And I can scroll down and see them. So this is a completely interactive page. And the whole beauty of this is now we've done this in Blazor with no JavaScript that we had to code, just C# and HTML. So, you know, let's say I wanted to clear this. I wanted to have a button to clear that counter. all I'd have to do is copy the button, maybe have it labeled clear, and then I'll change increment count to another method. So I have to write a method for it. So we'll write another method down here, private void clear count, and that'll just set the current count to 0. And then I'll call that when you click this button, so clear count. So now I've tied the action of this button to the server code clear count, which should change the current count to 0, which should then re-render the list with nothing in it. So let's see what happens. Go to counter, and I can click, 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 clear. Click, 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 clear. All right. So you can hopefully imagine where this is going. This is generating data. It's generating a list of items, but there's nothing saying you can't grab this data from a database. And that's what we're going to be doing in this tutorial. We're going to retrieve our data from a database, store it in a database, and be able to iterate through it and display it on a page. And we're going to use some additional Blazor components to do that in a nice way. So that's your counter and some of the enhancements I've made to it to show you how it works. Okay, let's check out fetch data now. This is the page that's going to respond to any requests to this link /fetchData. It's including a data object or a data namespace, which has an object in it. It's going to inject a weather forecast service. So this weather forecast service is code that's running in the background that can generate weather forecast data. We loaded it up back in program. Remember in the beginning I showed you, and I'll pop back over there again just to show you. We added this weather forecast singleton service. So it takes this object that we'll take a look at later, pretty soon actually, and has it running in the background all the time and can be accessed by any page by injecting it. So injection is something we use a lot in Blazor. So let's actually look at the weather forecast service before I go back. So I think that's under the data library and or namespace. So let's look at weather forecast service. And weather forecast service really is just a class. It's not, a service is nothing fancy, it's just a class. And it has methods and properties like anything else. These properties here are just an array of summaries that I can spit out: freezing, bracing, chilly, whatever. It's going to randomly pick some of these. Then there's a function here called get forecast async, and we're going to talk about async a little bit. I mean, that's a C# topic, which is technically outside the scope of a Blazor tutorial, but I'm going to mention it because a lot of the code runs asynchronously in Blazor for a good reason. Especially with web servers or web pages, you don't want anything holding up your user interface. You don't want anything to be waiting for anything. So if there's something that could take a long time to run, you often do it asynchronously. Now this does not take a long time to run because it just generates data randomly. But if this were going to another server to collect data, or connecting to an API on a weather service, or going to a database, those type of things can take some time. So you don't want the code to be stuck waiting for this to happen and it can't do anything else, because that'll freeze up your web server. Because you might have more than one person connecting to it. You might have thousands of people connecting. So while the code is running code to display portions of pages, you don't want it held up waiting for some slow running process. So we'd use these asynchronous method calls, which involve the use of tasks. And a task really is just a return value from an asynchronous method, but it's an object that contains the result inside of it. So this weather forecast array is what this getForecast method is going to produce, an array of weather forecasts. But it's encapsulated in a task, so that's why this generic task object is specified to our, the generic class is for a particular response type. This could be anything. It could be nothing. Your task could, literally return nothing, so it would just be task. Or it could return an integer and just be task of integer. But in this case, it's returning weather forecasts. So this method will return weather forecasts. And what this is using is an enumerable object that generates a list of objects, and we'll select weather forecast objects as the result of that enumerable. So it's just instantiating really 5 weather forecast objects, which we're going to look at too. And each weather forecast object just has a date, a temperature, and a summary. I'll pop over there so you can see that. This weather forecast is very simple. It's for properties that are set, and 3 properties that are set, and a 4th that's calculated. So it's a very simple object that just stores data. We're going to be using more of these kind of objects in the future. Often these are called data transfer objects, or they're just called model objects, most likely in a simple way, because it's just an object to store a set of data. We might have more than one weather forecast. So each weather forecast has a date, has a temperature in Celsius, and a summary. And if we have the temperature in Celsius, we can provide the temperature in Fahrenheit by simply converting it. So this is just a C# notation to calculate the conversion and return that if someone asks for the temperature F property. So back to the forecast service, this method again is going to produce an array of those, so array of these forecasts. And it's going to this is just making 5 of them, and I don't want to get into the enumerable object and how that works with select at this point, because that's just language embedded query and enumerable objects, which we'll do more when we get to entity framework. But this is just creating weather forecasts and setting some random data on it. And it creates this enumerable list, but then converts it to an array. So the whole thing returns an array of weather forecasts, which is what we said we're going to return up here. So that actually works. So don't fret about the details of this implementation. Let's go see how it's used. So I'll go back to fetch data. Okay, so again, fetch data is the URL. This weather forecast service is now available to us in our code because it's been injected. So where it was set up to run in the program.cs file, it's in the background, and we can refer to it by this forecast service object name. So it's like we're declaring an instance of it, but we're not really declaring an instance of it. We're just getting an instance of it that's already been managed by the application itself, running as a service. In this case, as a singleton, there's only one object running for the entire application. For no matter who connects to our service, to our web page, we're going to get one of these services. There's the page title. Now, right away, we have, so you can see there's C# code here. So the @ gives it away, and also the fact that you see if statements, which is C#. So this is interesting. If forecasts equals null. Okay, well, what's forecast? Let's go down. So let me go down. Before we look at this HTML, how it displays these forecasts, let's go down and see what's in the code itself. Not a lot. There is a variable, a member variable called forecasts. So this weather forecast array stores all of the forecasts. Now notice there's also, it's not equal to anything. So that's going to be a null reference when we start. There's no constructor in this class that we can see. So that's going to be null. Now this onInitialized async. Okay. This is a method that every Blazor component can override if you want to. There's an onInitialized and there's an onInitialized async. If we want to call any asynchronous methods, we have to use an asynchronous method to call it from. So this is why they overrode this onInitialized async. And onInitialized is exactly what it means. When this page is initialized, so when you first click on the fetch data page, this method will run. There's a implementation of it in the parent class that every component has that you don't see. But if we want to do something custom, like we want to run something the first time they hit the page, then we have to override this onInitialized or onInitialized async. So again, we do onInitialized async because we want to call an async method. And which one are we calling? Well, we're going to call our forecast service. So this is the object that we injected, and we injected it up here. So it's a service managed by the app. It has the method we saw before, get forecast async. Takes a parameter in of a date range, or a date, actually, that's just now, so the date only. So it's the date, it's not a date and time. Date only just extracts the date from the date time object, which includes the current time, just takes the day of the month, of the, whatever the current day is, and passes that into get forecast async. So that's the thing that'll go and generate 5 bogus weather forecast objects and put them in an array. So it's going to eventually return that array of those 5. So this await here is going to continue the execution of this code after this is done. Now remember, this could be a long-running process. This is something where it might have had to go to like the weather service, wait for an internet connection, get the weather. So this could take seconds to run. In our case, it's not going to because it's all running locally, but it could take a while. So again, this is going to wait for it to return. Meanwhile, other code can run. Not this code, but other code can run. And this will then, it'll come back to this code when it's done. So when the result comes back, it'll then proceed, take the result of this get forecast async, which is an array, and assign it to this variable here, which is our variable. So this asynchronous initialization method will run, and we'll set this forecast variable to a value. So when we start the application, this is going to be null. And this could take a while. So this could be null for a while. This thing could be sitting here at null for seconds if this were to be a real thing that was connecting to some weather forecast service. So it'll be null for a few seconds, and then it'll eventually change to that list of 5 array elements. So that's going to affect how we display our page, the fact that we have to wait for this. And I'm going to actually introduce like a forced wait so you can see how this works. But for now, let's just go to the top and see how this is implemented. All right, so let's go up here. So back to here, if forecast equals null. So as I mentioned, this forecast variable is going to be null when we first load the page because it's having to load these weather forecasts from somewhere. So what do? They show a loading paragraph, which is kind of nice. So that if the user's waiting, at least they know why they're waiting. It's going to show loading ... Now, else, which is kind of interesting, else if it's got a value, so it's not null anymore, we have this table that it's going to show. So it's going to create a table in HTML. The table has a header row, which has the date, the temperatures, and the summary. Then there's a body section of our table. And in the body of the section of the table, it's going to loop through all of the forecast objects in the forecast array that's no longer null now. And for each forecast, it's going to create a table row. So again, we're switching back and forth between HTML and C# here. So as soon as this tag's done and sees this @ sign, it knows, oop, I got a loop. Open curly brace. Oop, I have a tag, so this is HTML, and another tag, and then boop, oops, I've got C# code again. So what it does is it takes the forecast object, goes to the date property, and converts it to short date string. So that's going to show like a short representation of it, like January 1st, instead of like some long version of the date. And there's different 2 whatevers if you want to do long or short. Then there's the forecast temperature C, forecast temperature F, forecast summary, and then the loop. So for all 5 of these, it's going to keep going and draw it. Or spit out the HTML with the actual values plugged in. So let's run that just to remind you how this works. go to fetch data, and here it is. So again, that happens so fast because the service is running locally and it's just generating random data. So it doesn't have to wait for anything. So it just immediately populated this table based on running that loop, going through the weather forecast objects, plugging them in. There's that short date string. It's just the numbers and fake summaries and everything. So it got bogus data from the weather service and plugged it in. Now what I want to do is introduce an artificial delay so you can see how this works. So what I'm going to do here is I'm going to introduce a sleep to force it to sleep for a second or two. So I'm going to add a line of code here in this initialization. I'm going to await task.sleep, or delay, sorry, 2000, and that's in milliseconds. So it's going to sleep for 2000 milliseconds, or 2 seconds. So when we first load the page, this forecast variable is going to be null for at least 2 seconds, and then it's going to change. So what's cool is on the server side, when this initialization runs, it immediately is it's going to start with forecast being null, and it'll see this await, which is something that means keep going. Like, I don't stop here, you know, let other things occur. And the first thing that's going to occur is it's going to actually draw this up here. And I say draw, which isn't really the right word, but render this out. So it's going to go through here, and it's going to see forecast is null and render out this HTML. Then and that's going to go sent back to the client. The client's going to update its page to show that. Then when that's done, it'll know it's done, and then this is going to run, and it's going to await this. So once the forecast comes back and this variable changes, it'll also know that it's done waiting, so the task is complete, and then it'll re-render up here. So it's going to go back and rerun this, and forecast won't be null anymore. It'll re-render out the table, or actually render it out the first time, send that back over the SignalR, and tell the page to update that. So when we run this, we should see the loading screen and then our list. Loading screen should stay up for about 2 seconds. So let me click it, loading, and then there it is. So you can see that that was a very clean refresh too. So when I go back up and in, you can see loading, and then it refreshes it. So that's 2 round trips to the server at least. When I clicked counter, that was a round trip. It said go and render the counter page on the server and give me back this region. Clicking is another round trip to the server, which told it to increase the number by 3 and re-render. Clearing is another round trip to the server, again through SignalR, which told it to make it 0, re-render. Fetch data is a round trip to the server while loading, and then another round trip when it's done loading. And it's able to notify, actually, that that occurred. So this is the SignalR is a live connection that stays open. So it's always waiting for the next thing to happen. So whereas this was purely in the counter, something where it was an interaction that everything was a click, 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 click. Fetched, and so that was a click, send a message, and immediately got a response. Clear, send a message, immediately get a response. Fetch data is send a message, which means load the fetch data page. And then it's waiting, shows this, waiting, 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 up, and then waiting again, showed this. So these streamed down. It like came first as a loading page, and then, or loading message, and then a table. So it showed that when it was ready. Now let me stop this. Okay, so we've covered the shared folder, the pages folder, this weather forecast service, and the last thing we need to cover, and I could cover the areas, and I should cover that quickly. Areas.identity are the ASP.NET identity framework built-in pages. You can customize these. These are all Razor pages, as I mentioned before, so they're not Blazor. You can customize these to add additional functionality, but that's ASP.NET Core. I don't want to get into that in this tutorial. I'm going to leave that out, especially since Microsoft is planning to create Blazor versions of these pages in the future. So I don't want to get into too much detail with that. And the functionality that is provided by default will be sufficient for the application we're developing. So back now to this data folder. So the data folder, we handled this weather forecast and weather forecast service. Now the last thing we have is the application DB context. Now this is important. This is the object that represents everything that's going to be stored in your database. Normally it's just a regular class. It has a constructor, and there's going to be methods and properties we add to it later. Properties we add to it are going to be additional tables, because we're going to store additional data in our database than just the data that comes with the identity data. But where are those tables? Well, this object here, as you can see, inherits from this identity DB context. So in identity DB context, there are tables defined to store the users that sign up and log into the website. And I'm able to see that because remember when we first ran it and we applied the migration, which we'll talk about in a later video, it actually created the tables in the database. And the tables are accessible for us to look at in the SQL Object Explorer. So to get to that, I'm going to go to View and go to the SQL Server Object Explorer. And if you expand that out, you'll see there's a MS SQL local DB folder. And inside of that, there's going to be a database for all of the projects you're working on. Now, our project is Blazor Invoice App, so you're going to see that here. And this corresponds directly with the connection string that's back in appsettings.json. So you see that GUID 80925. Back here, you'll scroll over, I'll see there it is, Blazor Invoice App 80925. So it creates this file for each project that you work on, and I happen to have 5 projects going here at this given time. So let's go back to the DB context, and I'm going to open up my app, and I'm going to go to tables, and you're going to see here that there are in the application 7 tables. These are Microsoft defined tables. So these are tables that store the users roles, logins, claims, which we'll potentially talk about, who's assigned to different user roles is who's assigned to the roles defines the roles, tokens. These are all for Microsoft authentication. We don't have to go into the details of how these work for this tutorial. But if you want to explore Microsoft's identity framework more, you'll become more familiar with these tables. Let's just look at the users table. So if I open that up, I can right click and say view data. And you're going to see that there's one row of data. So what they've done is it's a data table that stores all the users. So there's a user ID that's internal to the system. In this case, they're using GUIDs, or global unique IDs, for the ID primary key of the table, which we're going to do in our application as well. There's a username, which is the username they signed up with. Then there's an email address. That's a normalized username, just means a all capital version of it. Email. Now, ASP.NET identity used to be used in a way where they'd have the username and the email be different. Since most applications have kind of dropped that idea, they duplicate the username and email as the same thing in the code that's provided by default in the template. So when you sign up, you give an email, but what it does is it creates the username using that email and the email as well. Email confirmed just means we click that link, but this would actually be if the link were clicked from an email, which it's not right now. The password hash is a one-way hash of the password that you entered. So it can't be reverse engineered. You have to know the user's password. The user has to know their password to get in. And then there's other secure variables that are stored. And then there's also other things like their phone number, whether two-factor's enabled, whether the account's locked out, how many failed access attempts there are. There's a lot of functionality in the Microsoft identity that we're not going to go into, but utilizes these columns. So for now, you don't have to really worry about it. But you have to know that there is a table called ASP.NET Users, and we're going to be referring to it because we're going to have to link users to this, specifically the user ID. So we're going to need to know the user's user ID, not just their email. But there's going to be a way for us to get to that. And in fact, there are Blazor components that keep track of that, and this login display component is one of them. And you can see that it refers to this context object, which has a user object on it, which has an identity object on it, which has a name property. And that name is the email address, so that's their username. So the username and the email are the same. If you'd like to, you can add more columns to this table and refer to them, which we're not going to do in this tutorial. But there are ways to not only add more columns, but customize the object and even ask for more information when they sign up. But that's beyond the scope of this tutorial. We'll spend more time on this application DB context when we actually add our own tables with custom data. Let me just do one more thing to finish up this tour through the template, and I'll go to the www root folder. And there's not much to this. There's just an icon for the application and a CSS folder with the Bootstrap library and some other things like the font, iconic fonts, and a site CSS. You might go into site CSS. This is where you would put any custom CSS that you might need to add to what isn't provided already in the Bootstrap CSS. So that's it for this walk through the template. In the next section, we're going to go ahead and start implementing our invoice system. All right, let's get started with making our invoice application. So we're going to base it on this template. We're just going to modify the template app to create our invoice application. So let's start by cleaning up some things that we want to get rid of. The first thing I want to eliminate is this weather forecast service. So that contains these two objects here, the weather forecast service and the weather forecast data object. So I'm going to just right click each of these and delete them. Now that immediately causes a problem because the pages that refer to it aren't going to work and the other objects that refer to them aren't going to work. So if I go down to program.cs, that's the first one that's not going to work. So we have to eliminate this singleton service, the weather forecast service. We'll be creating some of our own services, but for now, let's just get rid of that. And what I'll do next is I'll go to the actual pages and I'll eliminate the fetch data page as well, because we're not going to use that. And that should be good for now. Let me run that as far as weather forecast service. So that works. Now our fetch data page is still a link in the navigation, but the page has been deleted. So let's see what happens when I click it. See, I get the sorry, there's nothing at this address error. So the router looked for something at fetch data and there was no page that matched that URL. So it provided this sorry, there's nothing at this address, which is back here in app.razor. I mentioned the router before. Router had found where it would load the page and render it with the layout. In the not found case, it also uses the layout, but it just shows a paragraph that says, sorry, there's nothing at this address. So just deleting that page didn't crash the program, but it made that link useless. So we'll fix the links later when we add other pages. Now, we're not going to need some of these pages. We're not going to need the counter page, so I'm going to right-click and delete this. I'm going to keep the index page probably, because we'll change it to display what I want to display, but it will be the main page. And we will also get rid of this survey prompt because we're not going to be referring to it anymore. So let me go back to index actually and just delete the survey prompt reference, and then delete the survey prompts object here on the right as well. So that has cleaned up a lot of the stuff that we're not going to need for our application. I'll just run it to make sure I didn't break anything. And we're still good. Counter link doesn't work, fetch data link doesn't work, register and login still work, and home still goes to our index page. The first thing I'm going to do is take you through the database schema of this application. So there are 5 tables involved in this application. The ASP.NET Users table is the table I referred to before, which is built into the Microsoft Identity Framework, which we're going to be referring to from our other tables, because all of our other tables are going to be linked to particular users. So if you log in as a user with a certain username, you will have your own set of all of these data items. You'll have your own invoices with your own customers, your own terms, and your own line items. Each user who logs in is not going to be able to see the other users' invoice data, so we want to make sure that everything is linked up properly so they only see the ones that they own. Now, the invoice table here has its own ID, a create date, which is when it's created, a description, a customer ID, which links to the particular customer that the invoice is for, a terms ID that links to the terms of the invoice, and this is where you can define different terms like net 30 or net 60 or whatever other terms you want to define. The user ID here, which is going to link back to the ASP.NET Users table, how much they've paid on the invoice, how much you've credited towards the invoice, a tax rate for the invoice, and an invoice number. This lets them enter their own number for the invoice instead of having to refer to it by this long, unique identifier, which might not make sense to the user. Now, each invoice, of course, has line items. So each line item here refers back to the invoice it belongs to, has a description, a unit price and quantity, and a user ID because it also belongs to a particular user. Now, the invoice belongs to an invoice. The invoice line item belongs to an invoice, so we could get the user ID there, but for the purposes of consistency and security, I'm putting the user ID in every table to make sure we keep track of which user these data records belong to. This is optional, but it's the way I implemented this. This total price is going to be calculated because it's going to be the unit price times the quantity. So we're going to show you how to calculate that. Now, the customers table is going to be the particular customer for that invoice. So as a user, you could log in and set up your own set of customers, give them names, and they'll be yours and they'll have unique IDs. And same with terms. You can define your own terms. So you could have a net 30 term, a net 60 term, or whatever terms you want to define. They'll belong to you. They'll be your terms, and they'll be having their own ID as well. So all the IDs we're going to use in the system are going to be globally unique IDs. So these will be string fields. So this is the schema we're going to implement. So how do we do this? Well, we're going to use Entity Framework, and we're going to use Code First Entity Framework. So what we're going to do is create classes for these 4 additional tables that don't yet exist in our database. And then we're going to apply a database migration to actually create these tables in the database automatically for us. So let's get started with that, creating these objects. So they're all going to live in the data folder here. So let's create some objects in there. Now I'm going to create a couple interfaces because there's common columns that all of these tables I'm making have. And for one, they all have an ID column. So I want to enforce that my tables have an ID. So I'm going to create an interface or a contract that I can have my objects implement. So let me right click and add one of those. It'll be very simple. So I'll make a new item. It'll be an interface, and I'll call it iEntity. So all of my entities that I'm going to make are going to have if they implement this interface, they're going to have a requirement of an ID. So that's one of my interfaces. So let me keep that. Now I'm going to add another one, and I'm going to call this an I-owned entity. This means it belongs to a user in my system. So for it to belong to a user in my system, it has to have a user ID specified to it that's going to link back to that ASP.NET users. So public string user ID, get and set. So these are the two contracts I want to set up off the bat, these two interfaces. So let's create one of the simpler ones first. Let's look at the customer. So every user can define their own customers that they want to have in their system. So what I'm going to do is I'm going to create an object here, a class, and it's going to be called customer. So we're going to implement the customer table using this customer entity. Okay, so the first column we need is an ID. In fact, it's getting smart. It's actually trying to help me do it, and it will do that. It will kind of figure out that you're making a data class and give you an ID. But it's not going to be set to nothing. By default, I want to have it give it a GUID. So I'm going to say GUID.newGUID.toString. So this will be a globally unique ID that's unique across all, and it's going to be a string too. So it was thinking I was going to use an integer, but no, I want to use a string. So it's going to be a string property that will hold a GUID. Now, normally, Entity Framework will want to generate these IDs for you, but we are going to handle the generation of the IDs. So that's a philosophical question as to whether you have the database generate IDs for you or have your objects generate the IDs for you, or your code in that sense. But since we're using GUIDs, you can have your code generate them. If we were using auto-incrementing numbers that just increased one at a time, that would not be safe. You'd want to do that. You'd want to allow the database to generate those IDs. But since we're going to use GUIDs, every time we create a GUID, it's completely unique. So we have to tell the database not to try to fill that ID field in with a value automatically. So we're going to add this tag that says database generated option none. So it's going to this attribute here is going to tell it when it generates the classes and generates the entity framework objects for this, not to create in the database, or not have the database generate these GUIDs. So that's that. Now, since we've implemented ID, I can tell this to implement the entity interface because it has ID. So we're off to a good start. Now we want this customer to belong to a particularly logged in user too. So we're going to also have a user ID that goes with this. And that's another GUID, so it's going to be another that. Now I'm going to also set it equal to null and put the exclamation point on here so that it doesn't complain. We want to make sure that this object has a null value by default. We're going to actually populate this when we link it to a user, but to keep the code happy, or to keep the we use this exclamation points because the null checking in the compiler is going to warn us that a null value could be a problem. So we just tell it, no, this is okay, this is by design, we want to assign it to null. And the reason we're doing that is because we're going to have a navigation property under it, which I'll get to in a second. But let's do first the name. So the next column we need is a name. So all of our customers have names. So we can add another property, which is a name property, which we're going to have default to empty string. So we can create an object without setting a user ID and a name, and it will successfully create one with empty values and a null value for the user ID. I mentioned navigation property for this. We'll get to that. I'm going to add those later once we finish these objects. So these are the columns in the customer table. Let's continue. We'll come back to it, but let's continue by creating the, oh, before I do that, let me make this implement I-owned entity as well. Because it can, because it has a user ID in it. So this customer is both an entity and an I-owned entity because it has ID and user ID. All right, so let's do something very similar. In fact, I could probably copy a lot of this. The terms. So the terms table, invoice terms, we're going to create another object here. Add a class, call it invoice terms. And I'm going to paste in what I just did from the other one because it's going to have an ID, a username, and a name as well. So it's very similar to the customers table. So that's going to also implement I-entity and I-owned entity. So that satisfies those two contracts. They basically just have a name. So let's do the invoice one. That's a little more tricky. So let's move to that one. Let's go right click this and we'll make a new class for invoice. Now similarly, it's going to implement both I-entity and I-owned entity, which it's going to complain about initially because I haven't put these values in yet. So let's first put in the ID. So there's the ID. We have not database generated string, that's a GUID. Then we're going to have a user as well, just like we did before. So it's both has its own ID and a link to the user it belongs to, satisfying these two interfaces. Now we're going to have invoice numbers, and I'm going to have those generated. So I'm going to actually create an integer column here for an invoice number, and I'm going to let the database generate those numbers. So it's going to do that. This is a generation option. It tells the database to, well, when it creates the database, it tells it to add an option to the table to generate these numbers. So it'll go in order 1, 2, 3, 4, 5. Now we have some other columns here we're going to do. We're going to do a create date, and that's going to be the current time, so it'll default to the current time. We're going to do a description, which is also what the user can type in. We're going to do a customer ID because we know it's going to link to a particular customer. Every invoice belongs to a customer, a single customer. So we have a customer ID that's also a string. And we have an invoice terms ID as well. That's going to link to the invoice table. Now it doesn't know these link to those tables yet. We're going to do that. But I want to create all the tables first because we have to, it's referring to other objects that don't exist yet. Customer exists, users exist, but the invoice terms don't exist. No, they exist, but the invoice line items don't exist yet. So I'm going to go ahead and do that next. And we'll come back and finish all these classes. So let me add another class, the last class here, called invoice line item. Okay. And the invoice line item is similarly going to be a entity and an I-owned entity. So it's going to need the ID. It's going to need an ID, and it's going to need a reference to the user ID as well. Okay. And we're going to need other columns like the invoice ID, we're going to need a description, a unit price, a quantity. Description is an empty string, unit price and quantity are just default to 0. It's going to have a total price, which is going to be calculated, but I'll include it anyway. And I'll show you how to calculate that. Private set is on purpose because that's part of the calculated field option, which we're going to get to. So here we go. We have the ID, invoice ID, description, unit price, quantity, total price, and user ID. So these columns exist, and they exist in all these tables, but how do we relate the tables to each other? Like, how does it know the invoice ID is from the invoice table, and how does it know the user ID is from the user table? That's what we're going to do next. We're going to add what are called navigation properties right alongside these different columns. And that's going to tell the entity framework how to join the tables together. So let's start with the customer table, because that's the first one we did. Now, what is a reference to another table? The ID belongs to this table, the name belongs to this table, but the user ID is a reference to the application user table. That's the object that's defined. So what we do is we put what's called a navigation property right under it. This is what one looks like. So it's actually not application user, it's identity user. It's actually not that. It's called identity user. This is the object that will be created for each user. That results in that ASP.NET users table. But in order to reference that, we have to include at the top here, using Microsoft ASP.NET Core.identity. That's where that object is defined. So this user ID is going to map to the user ID, or the ID of the primary key of this identity user table. So notice it's defined with a question mark, so it can be set to null, because this in theory may not have a user defined, because the user ID could be null. So these things get populated automatically when you do queries, so it's good to have the ability to nullify them. And that also has to do with cascading deletes, which we're going to talk about, because that can be a scary proposition if you're not careful, where if you delete one thing, it ends up deleting a lot of other things too. So making these nullable is good, because that way it won't have a chain reaction and delete a whole bunch of things in your database accidentally if you delete one column somewhere. But that's a side note, we'll get to that. So now it knows that this user ID corresponds with this user object. So we can actually do the same exact thing in the, actually in all of our objects that have user ID, which is all of them. I'll go down to invoice terms first and just add it there. And then I will, which by the way also included that. Now let's go to the invoice itself and add the user ID there as well, which it also included this. So now it knows this belongs to this. Now we still have two more foreign keys. We have the customer ID and the invoice terms ID. So we need to put navigation properties on those as well, so it knows the customer ID belongs to the customer table and the invoice terms ID belongs to the invoice terms table. So the way that's going to look is for customer ID, we're going to have a nullable reference to the customer table right below it. And for the invoice terms ID, we're going to have a nullable reference to the invoice terms table. So now it knows what these belong to. Now this is more than just that, of just knowing. These are navigation properties. So we're going to be able to, like, if we have a particular invoice, say, give me the customer that belongs to it. I'll be able to say invoice.customer and then .name or whatever their properties are. So these help you navigate from one object to another to tables that are joined together. Now there's a feature in Entity Framework where you have to tell it to include the data from the joined tables, but we'll get to that later. But for now, you just know if you're joining tables together, or if there's references to other tables, in other words, foreign keys, you should create a navigation property to correspond to that foreign key, not only so it knows what table it is, but also to let you navigate to those fields that are as part of that table, which will make sense when we show you later. So that's these two. So every foreign key is accounted for here. Now if I go to invoice line item, I have the invoice, well I have the user ID I still have to account for, so let me copy that from here. And now the invoice ID. So that's going to be another reference to the invoice table, another navigation property. There we go. So now the entity framework with these navigation properties knows how to join these tables together, knows how to create the foreign key constraints, knows they're nullable because I can set a null to this. I can have a null reference, so it's going to let me do that. All right. Now let me go back to invoice because I think I left some things out. We have our description, customer, invoice terms, create date. We don't have our how much they've paid, how much their credit, and how much their tax rate is. So I'll add those columns as well. So we have how much they paid, 0 by default, how much credit we give them, 0 by default, and the tax rate will also have 0 tax by default. Now, there's a relationship that exists here between invoices and invoice line items. For every one invoice, there could be many invoice line items. We can create a navigation property actually to go to the many invoice line items from the invoices. I mean, we have a navigation here to the customer, which is a one-to-one relationship. We have a navigation object for the invoice terms, which is also one-to-one, hence one object. If we have many invoice line items, we can create a navigation property to let us get to those, but many has to be some sort of object of invoice line items that can store more than one. So something like an array, or what you end up using is a generic collection. So it's called the I collection. You create an I collection since there's many line items, so we call it invoice line items. And it's basically just a list of invoice line items. So this will start off with an empty list. But this navigation property will let you move from the invoice table to the line items that belong to that invoice by using the dot notation. So you'll be able to, if you retrieved an invoice object and you include all of the line items, you'd be able to say invoice dot invoice line items and access a list of all the line items that belong to that. So that's something we're putting in here. It's a feature of Entity Framework that we're going to utilize. So I'm including it here as another navigation property. The foreign key relationship is between invoice and invoice line items is already taken care of here, where we put the public invoice navigation property on the invoice line item itself. So that is what actually takes care of the foreign key constraint. But this additional navigation property here lets us maneuver to the invoices via an invoice object. And that's where having these things mapped into objects is very handy, because you can treat them like objects and not have to worry about writing SQL queries and joining data necessarily. So that's something we're going to do. Now I'm hitting build to make sure all my code is good. And it is, no errors. Now we're almost ready to include this data in our database. Now just creating these classes doesn't make them exist in our database. There's a couple more steps we have to do. So we have the invoice, invoice line item, invoice terms, and customers that we added. To make them actually part of our database, they have to be part of our DB context object. Now in this case, that's our application DB context object here. And you know it is because it is the one that in program.cs is used to add. So we add the DB context, and that's the object it's using. So Entity Framework is going to base its database objects on that object. So if we come here, we have to actually add our tables, our objects that represent tables, as members of this class. So the members of the class will go here. And what I'll do is I'll create what are called DB sets. So you create a DB set, which is a generic object, which is basically represents a table, a set of invoices, which is a table of invoices, using the invoice object. So it'll create a table to store invoices, it'll create a table to store customers, a table to store invoice terms, and an invoice line item table as well. So this will handle creating the tables when we get to that point. Now, there's a few other things we're going to do. So I don't like cascading deletes. Now, a cascading delete, what is that? In a database, if we had a invoice and we were to delete the invoice, an invoice could have many line items. If there still are invoice line items, but the cascading delete is enabled, if we delete an invoice that has 5 invoice line items, the database will automatically wipe out the line items, all 5 of them, and then wipe out the invoice. To me, that's dangerous. To me, I want this to never delete anything in my database unless anything that is referring to it is also gone. So if I were to manually delete all the 5 line items, then it would let me delete the invoices, but not before. If I try to delete invoices and there's still line items, I want it to fail. If I want to delete a user, but it refers to a customer, I want it to fail. Anything that still has a foreign key set that refers to something that exists, if I try to delete it and it would break the foreign key, I want it to not happen. So that is not the default behavior of Entity Framework. So you have to make it the default behavior. Well, you don't make it the default behavior. You change the behavior so that it doesn't do that. So there's a way to do this. It's called fix-ups. There are fix-ups, is what they call them. And the way I do this is I created a method here called remove fix-ups. And you're going to see how I use this. But what it does, and it's a pretty strange method, but every in the database, every table or every relationship has a, first of all, using the model builder, which we're going to talk about in a second, has relationships. So the relationships that exist between the tables, these are the foreign key constraints, okay? I want to go through any of these foreign key constraints for a given type, like if it's for the invoice or the customer or an invoice terms. I want to go through the entire model, find all of the foreign key constraints for that table, which is a given type, and get the foreign keys. And I want to change the delete behavior to no action. So it's not going to cascade delete on those tables if I call remove fixups for it. So what I have to do is I need to create yet another method. So this application DB context has a method built in that we're going to override called onModelCreating. So I'm going to implement that. So I'm going to scroll down and I'll paste this in. OnModelCreating. This is going to allow us to override some of the default settings that occur. Well, before I break this, let me close up my curly braces. We're going to do some stuff, and then we're going to call the base method. So we're going to add in some customizations to how it creates our database tables. Because I don't want the delete cascade. I want it to do nothing if you delete something, and not allow it to delete. I want those constraints to maintain data integrity. So I can call remove fixups 4 times on each of my tables, so that it's going to remove these cascading deletes from all of my tables because I call it 4 times and I pass in the type of the object I'm dealing with, which is my table. In this case, the 4 tables. So that's going to fix my deleting problem. So now I like the behavior of this better. It's not going to delete. If I try to delete something that has foreign keys, or it will not let me delete it. It won't just cascade and wipe those out too. Now there's a couple other things we have to do. This is just an oddity of the way I used the, and this took me a while to figure out, the invoice number in the invoice table. I had to say ignore the after save behavior. If you change the value. So if you change the value, will it actually send it to the database? And I don't want it to. So and that's kind of what's happening. The next thing I did is the calculated total price. So here's another thing you can do. I'm going to add this in. So notice these are all calls to the model builder object. The model builder is in charge of creating the data definition language for the SQL server. It's in charge of creating the tables. So the model builder, will add, like a default model builder action is to do delete cascade. So I had to tell it not to. So I modified the model builder. Then I changed this setting on the invoice number. And then now I'm changing the invoice line item object. I'm saying, don't create a column called total price. I'm saying this column in this object, this property in this object is a computed column. It's not actually a column I want you to create a column in the database. It's going to be a computed column, and this is the formula of how to compute it. It's going to be the unit price and the quantity. So now when it goes to create the invoice line item table, it's not going to add a total price column. It's going to add a total price column that is a computed column. It's not going to be a column that can store an amount. It's just going to always return the computed column of unit price and quantity. So now this has all my rules now. So this application DB context has my 4 tables that I've added, in addition to the other tables that are built into the identity DB context. That's those like ASP.NET User and everything. And has my remove fixups utility, which I use to remove my deleting cascades. I fix up the invoice number, and I fix the calculated column to be an actual calculated column. So this is where you customize everything to tell Entity Framework how best to create your tables in the database. So it has everything it needs, but we're still not done because these tables will not exist in the database. If I go over to my SQL Explorer, and I open this up, you'll see the only tables that are here are the ones from the identity. This was created, these tables, when we did that add migration button when we first ran our template. So things have changed since then. A migration is a history of all the changes that occur to your database as you're developing your application. When we first developed this application, we included the Microsoft identity, which included these 7 tables. But now we've added 4 more. So we need to migrate those tables in. They don't exist yet. We need to have them created and added to the database. So we have to add a migration, and that's what this folder here is. You don't edit this folder directly. This folder has objects that have the rules for how to create the actual SQL tables. So to do that, we have to go to the Package Manager console. And what we do is we say add-migration, and we give it a name. So the first migration had a name, initial migration, I think. But we're just going to call this DB1. So I'm going to, if I add more to the database, I would make a DB2, a DB3, or make changes. Like I can change things, and then I have to make a new migration every time I change it. Because remember, a database has a fixed schema. So we have to take the schema that exists now, which has these 7 tables, and we have to add more tables to it. So we're going to add the migration. And that's going to convert everything I've done in these objects. It's going to look at these 4 new tables. It's going to look at these rules I added. It's going to also look at the existing migration, which created these. It's going to see what's different. And then it's going to create SQL DDL language to add and modify the tables appropriately. So this is intelligent. It's going to do all this for me by adding migrations. So let me hit enter on that. And what it did is under the migrations folder, you'll see it created a DB1CS. Now you don't have to look at this thing, but it's got all of the things I just added are in it, including foreign keys and what to do indexes and stuff. So I can close that. But then it's not going to apply it to the database immediately either. Just like when we ran the program the first time, we had to click that link to have it apply the migration. Well, we don't have to do the link this time because that link isn't going to come back. It's not going to do it. We have to do it manually, and the way to do that is to do update-database. So every time you add a migration, you have to update the database. And you can see all of this DDL language just spit out. It creates the tables, and it adds columns, and etc. So now if we go up here to our SQL Object Explorer and refresh the tables, you can now see that our customers table, invoices table, invoice line items, invoice terms table are all there. And what's great is it mapped it all to SQL data types. Like the whole mapping between our C# objects and the database is all done automatically. Like let me look at invoices, for example. You can see that it created the ID as a string. It made an invarchar. User ID is also an invarchar. Invoice number is an int. Create date's a date time 2. The monies are float, so doubles became float. So it knows how to map the values to another. It actually got kind of smart too, like description. It's like that's probably longer than an ID. So it used the max field length for that instead of just like 450. So Entity Framework has some intelligence in it that helps you map these columns to the types you want. Now, if you don't like the mapping it did, you can always go back in to your objects and either put more information in here, more of these like database generated tags. You can there's other tags that let you pick the exact type it'll map to, or you can also do it in here back in the model creating section. You can do that. You can put things in here to have it pick certain SQL types that you want it to pick, because it may not figure it out on its own the correct way. But I like what it did here, so I'm going to keep it. And now we have a working Entity Framework set of objects that will map to the database. So we make changes to the database, it'll be reflected in these objects, and if we make changes to the objects, they can be reflected automatically in the database. That connection is what Entity Framework is in charge of maintaining and working with. And it's super powerful. You could do a whole course on Entity Framework, and there are courses out there that are good. If you want to learn more about it, I recommend you take a look at it. Now I want to prove to you that this mapping is actually working. So what we're going to do is I'm going to actually put some data into one of these tables. And then I'm going to retrieve the data and show it on my index page. And this is not what we're going to do for the final project, but I think this will just give you a kind of an intro to how Entity Framework works in reality. So I'm going to go to this customers table, and I'm going to actually view the data, and I can actually enter data. So I'm going to leave the user ID null right now because we're not going to care. The IDs we can make up. I mean, they're GUIDs, but they don't have to be GUIDs. I'm going to give this a name of, I don't know, customer Apple. Can't do that. User ID can't be null. And actually, that's a foreign key reference. So I have to put a valid piece of information in there. So it's going to belong to me. So I've got to get my user ID. So let me go into into ASP.NET users and show the data there. And there's my user ID. So let me copy that. I'm going to go back to customers and paste that in there. So customer 1 is my customer, and it's called Apple. Customer 2 will also be mine, and it'll be called Microsoft. Customer 3 will also be mine, and it'll be called Tesla. So these 3 customers belong to me, and they're in the table. So how would I retrieve this data and show it on my page? The first thing I'm going to do is actually change the way we access the database a little bit. And to do that, I've got to go to the program.cs. We talked about this before, how this DB context here allows the user to connect to the database. There is another way to do it. It's called a DB context factory, which lets you create connections on the fly to the database that you need. There are advantages to using this. I don't want to get into the details as to why, but I'm going to change this statement here a little bit. And this becomes an issue later, so I'm going to do it right away and get it out of the way. It actually becomes an issue with concurrency and some other issues, things happening at the same time. So I'm going to change the DB context to add DB context factory. The options are similar. It still is this object, and it still has to use SQL Server. But then there's a service lifetime option, which I want to set. And I'll make it transient. And I'll come back to this later as to why I want to do this. But that is what I need to change for there. So that doesn't change the functionality overall. It's still able to access the database context. Whoever needs it is going to be able to access it without any other changes. So how do we access the DB context? So let's go to the index page. Now, if you remember, we had in the weather service, we had an inject at the top, which let us get a reference to the weather service. We're going to do something similar to get an access to the DB context. So here on the index page, at the top, we're going to inject the DB context factory. So it's a DB context factory generic type of our application DB context. And we're giving it a name of DB factory. Now it's not happy because we need to include, if I ask for the auto tip, it wants to include a couple things. It wants to include Blazor Invoice App.data and Microsoft Entity Framework Core, which I can do, and that fixes it. And I can fix this one as well by including the reference to Blazor Invoice App.data. But since this is something we might do in other places, I'm going to actually cut this out, Control X, and go to the imports.razor I showed you before. So if I go down here, I can include it here. And if I include it here, it's included on every page now, so I don't have to worry about that again. So every page has those includes. If I save it and go back to my index, you can see that it is actually still working. Now we want to actually get the customers out of the database and show them on this index page. So what I'm going to do is include some code here with an initialization code. So as I mentioned before, to initialize, we can create this method here. So this method is going to run when index loads the first time, if I close the curly brace correctly. This will load. And now from here, we have access to our DB factory. Okay, so the first thing we need to do is actually use our DB factory to create a connection to my context. So let's get a context out by doing this. var context equals dbfactory.create dbcontext, that will give us a connection to the database. Then we're going to need a place to store these customers, so I'm going to make it a member variable here. private list of customers, and it's going to start as null. So it's a list of customer objects. These are our entities, our database objects. And then the last thing we need to add here is a line here to call this context's our database context. Now that was our application DB context object. One of the properties was the customers table. As you can see, if I go back, this is the customers property. So we can get to that and say, give me a list of everybody in there. So take the whole table, convert it to a list, and await. Remember, await means it could take a little time. So it's an asynchronous call. It could take time to go to the database and get the data and then assign that to customers. So this will load all of the customers into this customers list when this page is loaded the first time. So we have to actually show them. So let's do something similar to what we did on the weather page. If customers is null, then we're going to show a paragraph that says loading customers. Else, we're going to loop through the customers. So for each customer C in customers, we'll just put paragraphs. So a paragraph with at, so we're going back to C dot name. So we're going to list the customer name. So for every customer object, we're going to list the customer name. So let's see if this works. It did. So those 3 rows that I stored in the database came through and are stored here. So that's generally how the entity framework works. You have this context factory, you retrieve a context from the factory, and then you can use the context to access the data. Now this is a read request, so what it does is it does like a select query from the database and returns all the rows. But there are options to update, delete, insert, etc. Add customers, delete customers, which we're going to go through later. But before you get too excited, I'm going to introduce a layer of abstraction, because what we have here, we do have a layer of abstraction here. I mean, we have these objects like customers, invoices, invoice line items that separate us from the database. But this is still kind of user interface code here. This is code that's designed for the user interface mainly. And it's directly connecting to the database here. This is directly working with our customer, invoice, invoice line items, invoice terms objects in the GUI code. Not the best practice in the world. You want to have one more layer of abstraction at least to enforce rules. Like, I just selected all the customers. There's nothing in here that says, oh, they have to be my customers. This just gave me all the customers. There is direct access to the database columns and the database rows without any filtering, without any, are these mine, etc. So we're going to create a go-between layer where we're going to create an abstraction layer called a repository. And this is a pattern, a software design pattern that's very popular with these kind of applications. It's a repository that's going to allow us to interact with the database, but not directly. It's going to create another set of objects that we can work with that we pass back and forth to the repository, and then those are converted into database objects. And there we can apply rules like security, logic, business rules, any integrity issues we have to do. we don't want this even to care about how these tables are joined together. I mean, because that's not something the user interface would ever care about. Very often you're going to have like one line of code here that's going to be very simple. Or if a button clicks and the person wants to submit something, it'll be another line of code that's simple, and it just takes the input, gives it to the repository, and then that is what is going to do the work. You got to keep the code in here simple. We're not going to want to have all of this database code in our graphical user interface page. So we're going to create a repository to do all this. So that's another layer of abstraction, but it's a good practice. There are other ways to do this. The repository pattern is one. It's not the only way to do it. It's not the best way to do it. It's just a way I chose. What the best is depends on your project. There's tons of debates out there as to what works best for different projects. You don't know till you try sometimes. I'm just going to present my solution, where I create a repository and I go a little bit beyond repository and include security in the repository, which I haven't seen too many examples that do that. So I'm going to go ahead and include the security issue. And the security issue in our case is that we only access data that belongs to us. So each logged in user is only going to see that user's data. It's not going to see invoices for other users. So I want to enforce that right into the repository, so there's no guesswork as to the fact that we're getting the data that belongs to us and only the data that belongs to us. And I don't want the graphical user interface people who are working on this page to have to worry about that. I want it to be seamless. So we'll get into that. I'm going to take a little detour now to cover Entity Framework. If you're already familiar with Entity Framework, feel free to skip this section. I'm going to add a page right now that's not part of the application, but I'm going to use it to demonstrate how Entity Framework works. When we actually write the code to connect to our database, we're going to do it through a repository. But this will show you how to do raw manipulation of the objects we just created for our database using Entity Framework. So what I'm going to do is go over here to the Pages folder and add a new page, Razor component, and call it Entity Test. Now this is going to be accessible via URL/entity test, and we're not going to create any user interface navigation links to this. We're just going to go there to see what this page offers as far as demonstrating how the Entity Framework works. So let's start by putting in an uninitialized async method that will run when the page loads. And the first thing I want to do in here is figure out who is actually logged in. The way we can do that is inject an authentication state provider. So I'm going to do that at the top of the page. And the next thing we can do is actually inject our database context factory. This will allow us to connect to the database. Now what I'm going to do first is actually use the authentication state provider to determine who's logged in. So let me access that. What this does is it actually gets the authentication state from the authentication state provider. And inside this authentication state object is a user object. And the user object will tell us who's logged in. And we'll also have what are called claims. So that's additional information about the user. So we're going to be able to get the username, the user ID, etc. from this object. Now the user ID is a claim, and it is accessible using this. Let me make this wider so you can see it. It's a very long name for a claim, but it's a claim that uses this as its name. And this is the user ID. So this is going to correspond to that globally unique ID, that's the primary key of the user table. So we need to know that because all of our other tables reference that user ID. Now we need to include the library for the claim object, which is system.security.claims. So once this runs, we'll know who's logged in. Now, If there's no one logged in, then that's going to be null. So we want to make sure that we're only proceeding if someone's logged in. So if UID is not null, then we're going to do some of our demonstration code in here with Entity Framework. So to get a connection to our database, we have to use the DB context factory to access a DB context. And that's what this does. So we just call the DB factories, create DB context async method, and await its result. And then we'll have a context object we can work with. The first thing I want to show you is how to create objects for the database. So we have customers, we have invoice terms, we have invoices and invoice line items. Let's create examples of all of these. I'm going to start with the customer object. So just to remind you, the customer object is a ID, which is generated automatically, a user ID, which corresponds to the UID of the user in the Microsoft Identity ASP.NET Users table, and then the name, which is a string, which is just the name of our customer. It's a pretty simple table. So let me go back here, and here's an example of creating a customer. Now, before we do this, this claim object has the user ID in it as its value. So I have to do one more step here. String user ID equals UID.value. So with that user ID, which is that global unique ID from the table of users, I can assign that to the user ID of our new customer. That way this customer will belong to the user ID of who is ever logged in right now. And we're just going to call it customer1. So we're actually creating a new instance of the customer class from our data entity model. Now I can also make a couple more of them. So let me make, in this case, 2 more. So I'm going to create a customer C2, a customer C3, and just call them customer 1, 2, and 3. Nothing creative, but hopefully it'll give us the idea of how this works. Now, this doesn't actually save anything in the database yet. All this does is create these objects. Now there is a collection of customers in our context, and that is accessible with this method here, context.customers. In order for these to end up in the database, we have to add them to that collection. So all I have to type is context.customers.add and add C1 to the collection. And then I can add C2 and C3 as well. And then as soon as I run await context.savechangesAsync, it will go ahead and write these 3 customers into the database. Similarly, let's create some invoice terms. So here's an example of an invoice term, and I'm only going to create one of these. It's, again, we have to assign the user ID so we know who it belongs to, and just give it a name. And then I can do the same thing. I can do context.invoiceTerms dot capital I dot add terms1, and then I can save the changes of the context. So await context dot save changes async. Now I chose to add the 3 customers and save the changes, then add an invoice terms and save the changes, but I could have actually waited until all of these were added to save the changes. So if I went ahead and delete this, that's okay. It's just going to add all 4 of these, or commit all 4 of these changes to the database at the same time when I call this context.savechanges. So the next thing we want to create is an actual invoice. Here is an object invoice being created. So we have invoice I1 equals new invoice. We're going to set a few things here. The invoice terms ID will be this new invoice terms that we created. The user ID, again, is the user ID of the currently logged in user. We're going to start them off with no credit. The customer ID will be the first customer up here that we created. Nothing's paid on it yet. It has a description of first invoice, and it has a tax rate of 5. This satisfies all the required fields I need to set for the invoice. So that will be an appropriate invoice when we go to save the changes. Now I'm going to make 2 more. So this invoice 2, same term, same user, same credit, paid, tax rate, slightly different name, and it's for the second customer. The third invoice will be same term, same user, same amount, credit and paid, same tax rate, different name, but it'll also be to the second customer. So our second customer will have 2 invoices, and the first customer will only have 1. Now I can add these to the database by going to the Invoices collection and add them to there. So I can add I1, I2, and I3. And then again, I can save the changes if I want to at this point. And similarly, I could decide if I want to actually remove the save changes I did up here and save the changes after all of these items are added to the database. So that's essentially how you create objects and add them to the database. It's as simple as creating instances of the objects in your data model, populating them with the correct properties, adding them to the proper collection in the context, and then save the changes. But we're not done yet because I want to add a few invoice line items as well. So let me put those in, and I have 5 I'm going to put in. And what they are basically are line items for, in this case, the first invoice, for computers at $555 each, 2 printers at $250 each for the first invoice as well. The second invoice is going to include a dozen apples and 5 oranges. And that's for the second invoice, both of those. The third invoice is going to have a quantity 20 of a stapler at $12.95 each. So now all of our invoices have at least 1 line item, and the first 2 have 2 line items. And again, I have to add these to the proper collections. And I'll add ILI 1 through 5. And I'll actually move the save changes now down below that final set of data. So all of our additions to the database are going to be saved in one transaction to the database. So that was how to add rows to the database. I'm going to cover now how to search for rows in a database, how to search for objects, and then how to update them. So what I'm going to do is I actually want to change all of the invoices for customer 2 and adjust the tax rate. So first we have to retrieve them. So how do we retrieve data from the database? Well, what you do is similar to SQL. You actually have to create a select statement with a where clause, because in this case we would want to say where invoice customer ID equals the ID of customer 2. So this is how you do it in Entity Framework. We create a variable to store the results, and we call on the collection. So this is the same object that we were dealing with to actually add things to the database. It has a where method. The where method is similar to a where clause in SQL. In fact, it will be mapped to a where clause in SQL when it's applied to the database. And the where clause takes a lambda function, and the lambda function will provide a expression that will narrow down which records we're looking at. So in this case, we start with a variable name that we create just for the where clause. This will be a stand-in for each invoice. So this is the equivalent of saying, like, the invoice object itself is going to have some sort of place in this query. So for every record we go through, the invoice its customer ID, will be compared to our customer 2 object's ID. So this is going to go through all of the invoices, and the ones that match the customer ID being customer 2's ID will be the results of the query. So this will be mapped to a SQL query that's like select star from invoices where customer ID equals whatever the ID of customer 2 is. ToList async actually executes the query, which is why it's the async method. It goes to the database and executes that query. and returns a list of results. So if there's 0 results, it'll be an empty list. If there are 1, or there'll be a list with 1 item. However many there are, it will produce. Now, if you see where, if I hover over the where, you can see it returns an iQueryable of invoice. And the actual toList async is what's going to return the final value, which is a task, of course, because we're waiting or awaiting it. It's asynchronous. But it's a task of list invoice. So in reality, this is a list of invoices. So I'll put it in there explicitly so you know what's being returned. So that's what is going to come back from this query. So now that we have a list of all the invoices, we can loop through them and make changes if we like. So I'm going to do that. I'm going to actually go through all of these, and I'm going to change the tax rate. So I just do a for each loop for each invoice I in the customer 2 invoices. Set the tax rate to 10. It was 5 before, and we're just going to change it to 10. So that's going to modify whatever invoices belong to customer 2. And then I can go ahead and save the changes. So that will now save those changes at this point in time in a second transaction. The first transaction just added the data. This second transaction commit will just apply all of the changes I just made to all these invoices. So that was a query that produced more than one result, possibly. So there could have been no invoices that matched this where clause. There could have been 100. If you want to do a query that results in one invoice, let's say we're just looking for one object, one invoice, we can do a slightly different query. It's not much different, but let me show you what this looks like. So I'm going to do this. I'm going to do this query here. We want to change one customer in this case. We want to go to the customers collection and give us all the customers where the customer's name is equal to customer 2. So this is only going to match one customer. In theory, the way this database is set up, it could match more than one, but it's not going to in our case. So we're going to expect it to return one result. So when you expect your query to return only one result, instead of using toList, you can call first or default async. What that will do is return the first result or null if there is no result. So that's what the value of this will be. Null or one result. So it's not going to be a list of invoices, or in this case customers actually, but it's going to be one. So I can say customer to change, and that's going to be the result. Now, since it could be nulled, I of course have to put the question mark here to make it a nullable object to get rid of that warning. So one result should come back. It'll be stored in this customer to change, or it'll be null if there are no customers. So now let's actually make the change. I'm going to put an if statement here because of the possibility of it being null. So if the customer to change is not null, set the customer to change name to test customer 2. I'm just changing the name, and then save the changes. So that's the example of just doing a select query out of the database where you expect only one result. It doesn't mean there is going to be only one result, but you're expecting one. So you decide to just take the first result or null. So now that I've shown how to create data, update data, query data, let's actually select all of our invoices and display them on the page. So let me put one final query here, and that'll be invoices. Now notice I haven't declared invoices yet. Will be just all of our invoices. So, and actually no, not all the invoices. I'm going to do where the customer ID is the second customer. So we're going to look at all of customer 2's invoices on our page. Now I want to create a variable as a member of this page class to store all of the invoices that are going to come back from that query. And it's got to be a member variable because I want to access it in the HTML above. So I'm going to go back to the top here where I like to put these things and put it right here as a private member. Initially it'll be null, so I'll set it to null here. And I can get rid of the warning too by doing that. Not that actually, but that. So a list of invoices, initially null, which will not be populated until the very bottom here with this query. So let's go up and display these invoices. So I have a little bit of HTML up here I'm going to put in that will produce a list. Okay, let me put it in. Let's take a look at it. So first thing it does, if invoices does not equal null, it's going to start creating an unordered list in HTML. It'll loop through all the invoices, and it's going to have a list item for each invoice. And each list item is going to be a sub unordered list. So that way we have multiple lists indented so we can tell one invoice from another. The first thing it's going to show is the ID of the invoice, and then the invoice number, the customer ID, the invoice terms ID, the amount paid, the credit, and the tax rate. So this is the basic information that's in an invoice. Now let's run this project and see what we get. So I'm going to have to manually go to this link /entity test because there's no GUI navigation to get there. So let me run it. Let me log in. And then manually go to that URL. All right. So you can see for customer 2, we have these invoices. We have 2 invoices, and it's showing us all of the information that's in the table, including the ID, invoice number, customer ID, invoice terms ID, paid amount, credit amount, and tax rate. Now, every time we hit this page, it's going to create another set of invoices every time because the code just does that. Every time it loads, it creates 3 customers. It creates a set of invoices, a set of invoice line items. So this, if I refresh the page, I'm going to have more data in the database. It's not going to show it because it's only showing the new customer that I make each time. But if I go into the database, I should see a whole lot of data. So let me go back here and go into the database. And if I look at my invoices table, you'll see there's a whole bunch in here. So they're going to start building up unless I delete them. So in order to make this program not just create tons of data, I'm going to go ahead and show you how to delete data too. So actually what I want to do is delete the data before we create any. So instead of deleting it at the end, I'm going to put some deletes in the front here. So what I'm going to do is clear out these tables before I add any data to it. So clear out the tables. And I can do that by doing this set of commands. And let me explain these. In fact, I'll put a context dot or await context dot save changes async at the end of this, just to make sure it saves these changes before we go on and make more data. So the first query is a simple query from the customers table where it'll select every customer that has a user ID of the currently logged in user. So that's all of my customers. And then it'll loop through each one and it'll call the remove method on the customer collection. And if I pass that each customer into that, it's going to mark it for deletion. So this should delete all the customers. I do the same thing for invoice terms, the same thing for invoice line items, and the same thing for invoices. And when that's all done, I save the changes. So by the time this runs, the user should have no data. So that when I go and add this data, it'll be fresh, and this is all that'll be in the database. So we won't junk the data up with too much data. What I want to do is come back up to the top here, and I want to discuss the data from the other tables. So we're showing just the invoice table here. All of these fields are in the invoice table. Now, what if we want to include, for example, the customer name? We can get to the customer table via the customer ID and get the customer name. If this were SQL, we would join in the table and we'd be able to get the name. Same for invoice terms. We would just join the table in and get the name that way. Also, we could potentially bring in all the invoice line items for this invoice, which we could join in, or we could do a separate query just to get the invoice line items for this table. Now, what I'd like to do is show you how to do that using the include statement. And what that does is create join queries when it goes to the database to retrieve the data. Now, in our case, we have an invoice object. And in our invoice object over here, we created what are called navigation properties. Anytime we had a foreign key, we put right under it this navigation property. What this does is allow the entity framework to have an object to store the data if you were to do a join and join in the data of that object. So that's this customer object corresponds to the customer ID here. This invoice terms object also corresponds to this terms ID. So these are two navigation properties. One is called customer and one is called invoice terms. Now, invoice line items works a little differently. If we go to invoice line items, and I'll go over there, you can see it is associated with an invoice ID. So we could put a navigation property to go back to the invoice. But we're not asking to do that. We're asking to go from the invoices to the invoice line items. So since this set up a foreign key relationship with the invoices table, where every invoice line item is associated with one invoice, in databases, you know that automatically corresponds to the fact that now there's a one-to-many relationship between the invoice table and the invoice line item table. So if I go back to invoice, that allows me to put this collection here at the bottom. It's a collection of invoice line items, and this will represent the mapping of all of the invoice line items to the invoice itself. So we'll be able to use this to join in those as well. So how do we go about doing that? We go down to the bottom, and in the where clause, we just add some additional .includes. So I'm going to say include the data that will be mapped to the customer navigation property, join in the data for the invoice terms navigation property, and then also bring in the invoice line items via that navigation property. So that will do the appropriate joins to bring the data in. So going back here, let me start with the customer name and invoice terms name. So I'm going to add a couple rows here. And the customer name, we use the navigation property. So it's i.customer, which is that property, .name. And then for invoice terms, we do the same thing. Refer to the navigation object and then call its member property. Now you'll notice these are nullable, so normally you may not join this data in, so this could be a null object. If I didn't include, they would be null. So they're not going to be null because I'm including the data. So I know that. So to get rid of this warning, I'll just put in the operator here to ignore that. Okay. So now if I run this, we should see the names as well as the invoice information from the invoice table. At the entity test URL. And we do. See, we have the customer ID, but then also the customer name and the terms and also the name of the terms. And that's down here as well. So the only thing we have to do now is just include the line items for these invoices. So let me go back to the code. And what I'm going to do is include just a loop to go through all of the invoice line items So after I show the tax rate, right below that, I'm going to insert this loop. So what it is it's just another line item, but inside that line item is going to have a set of the invoice line items. So each one has an ID, description, unit price, quantity, and total price. So this now should run and show us all of the line items themselves. Log in again. Entity test. And you can see for each invoice now we see the line items as well. So the first invoice has the apples and oranges, and the second one has the stapler. So hopefully this gives you a good introduction to how Entity Framework works. There's a lot more you can do with it. I just wanted to give you a basic introduction to get you off and running as far as how we're going to use it in our application. Now, in the next section, we're going to actually create what's called a repository, and that is going to add a level of abstraction over Entity Framework. This isn't the kind of code you want to put in your user interface pages. You could, there's nothing stopping you from doing it, and then maybe in some quick applications or something you just need to do quickly, you can do that, and there's nothing wrong with that. But you tend to want to separate the details of how your database works from what the user interface looks like. So we create often, there's a lot of ways to do it, but you create an abstraction layer of some sort. We're going to use the repository model with a unit of work. There are other ways to do it. There's no best way to do it. This is just one way I like to do. And even, as I said before, you could, in some applications, just use the Entity Framework directly if it's simple. But you can enforce more business logic and security and other things if you abstract it out a little bit. And that's what we're going to do in our repository model in the next section. To get started implementing the repository model, we're going to create what are called data transfer objects. These objects are going to correspond with the database objects that we just created. We have our invoice, invoice line item, invoice terms, and customer, and also the user. We're going to create objects that map to these objects one-to-one. We don't want our user interface code to interact directly with these objects. We want to go through a layer of abstraction through our repository. And we're going to be able to map the data from one to the other pretty easily using a library called Automapper. And there'll be other logic that we add to manage security. But let's get started by creating the data transfer objects themselves. So let's create a folder in the project. So I'm going to right click and I'm going to add a new folder. I'm going to call it DTOS for DTOs. And what I'm going to do first is create a couple interfaces, just like we have for our entities. We had our owned entity and a regular entity. So I'm going to create what's called an interface, but I'm going to call it a IDTO. So our DTOs will inherit from this if they're going to have an ID, which all of ours do. So let me put in public string ID. So all of our DTOs that implement this interface will have to have a ID. Now I'm also going to do the owned DTO, like we have an owned entity. So let me add another interface for that. And I'll call it IOwned DTO. And then that one is going to have the user ID, just like our IOwned entity does. So this corresponds to that. Now we can actually get started making our DTOs that match the objects that we already have. So let's make the first one. Let me right click here and do add class, and I'll call it customer DTO. This is to distinguish it from the customer class. but it's going to be a mapping of the fields from the customer class. So if we look at the customer class, we can see that there's a lot going on here. We have the database annotations here. We have navigation properties. None of this is going to be necessary because these are abstractions of the implementation that are tied to the database that we don't actually want to show the user. All we want to show the user is the fields that are necessary. So the ID, the user ID, and the name. So I'm going to go ahead and put those into the other file, the customer DTO. So let me come over here and I will put them in. So notice they just stand on their own. There's no annotations or anything else. The customer DTO is easy because it has just the ID, user ID, and a name that can implement our iDTO and our iOwned DTO. So that handles our customer. So similarly, the terms are easy. So we can do our invoice terms DTO. So I'll add another class for that. I'll do invoice terms DTO. And that's going to be very similar, in fact, identical. So I can actually look at the customer DTO and just copy these. And I can also copy the fact that it implements the two interfaces. Okay, so the next one I want to do is the invoice. So let me create an invoice DTO. And that's also going to implement our two interfaces. They're going to be read until I actually put the ID and user ID in here. And here are all of the columns I need to put, all the properties. So let me go through these. We have our ID, which maps to the ID in the invoice. The create date maps one-to-one, the invoice number, description, customer ID. I'm going to come back to customer name in a second. Invoice terms ID and invoice terms name I'll come back to in a second. Paid, credit, tax rate, invoice total, and user ID. You might be wondering why I put customer name and invoice terms name in here. These are not properties of the invoice class. These are properties of the customer and the invoice terms table. But what I can do if I add these in here is I'm actually able to map the customer name and the invoice terms name into this table whenever I retrieve an invoice, if I want to. It would be kind of nice if when I retrieve an invoice that I receive objects that have everything I need in them. I don't have to go and retrieve the customer objects for the customer ID in order to find its name. And likewise, I won't have to go and look up the invoice terms ID in the invoice terms table and retrieve a separate object just to get the name. In database terms, what we're going to do is we're going to be joining in that information and including it here in this invoice when we retrieve invoices from our database. So keep that in mind, and when I come back to implement this, you'll see how we do that. Now right here, I'm going to add the last object. So let me add the invoice line items. So that's an invoice line item DTO. And it is going to have a set of properties too. And here are those properties, which map exactly to the line item object in my entity, in my data folder as well. So here we go. This is an iDTO and an iOwned DTO as well. So now my DTO objects are complete. I have a DTO that matches all of my entities. Save them all. Now I'm going to create another folder for us to put our repository logic in. So let me do a right click up here on the project and do a new folder. And I'm going to call it repository. And the first class I want to put in here is an interface. It's going to be a generic repository that I'm going to be able to use to create repositories for each of my entities very easily. We're going to have a total of 4 repositories because there's going to be one for every entity. Our invoice will have one, our invoice line item will have one, our invoice terms will have one, and our customers will have one. We're going to group them all together too in a master object after that, but let's get started by doing this generic repository. So I'll define the interface for it first. The generic repository, which I'm going to call generic owned repository. And I'm calling it an owned repository because I'm building in logic to make sure it keeps track of who owns these objects. Whoever is logged into the system is the person that's going to own these. So you could create a repository that doesn't keep track of that as well, if you'd like. But all of our objects are owned by the logged in user. So I want to make sure I take that into account. So here is what that is going to look like. It's going to be a generic class as well. So it's going to work on 2 different types. It needs to have, I'll call them T entity and T DTO. What it's going to do is it's going to be able to map from our entity framework object, for example, invoice, customer, invoice line items, and invoice terms, these objects, to its equivalent DTO. So when we actually create a concrete instance of this class, we're going to pass in the name of the entity and the name of the DTO. So in our case, for the invoice, we would pass in invoice here and invoice DTO here. It's going to have some criteria on these. We want to make sure that these are not just any types, but they're going to be specifically the types that we have created based on the interfaces that we created. So I just added this. T entity has to be a class, and it has to be an I entity, and it has to be an I owned entity. It has to meet all of this criteria. So it has to be an object. It has to have an entity interface, so it has to have an ID column. It also has to be an I owned entity, so it has to have a user ID column or property as well. The TDTO is similar, it has to be an object, but it also has to have the ID and user ID properties as a DTO. So DTOs that we've created so far will satisfy this, and all the entities we've created so far will satisfy this criteria. So that limits us down to only doing these kinds of classes, which is important in this generic class because I need to refer to the ID and the user ID in the implementation without knowing what object it is. So I have to make sure that it knows it's these interfaces. Now there's going to be a set of functions that every repository has. And essentially this is to handle your create, read, update, and delete functionality on your entity. So I have these functions that I've defined in the interface. And the first one is called getMineById. And what that does is it'll retrieve an object that belongs to you based on its ID. So if we want a particular invoice, and it's my invoice, I would pass in this claims principal user object, which we'll talk about later. This represents who is logged in, and then the ID of the invoice I want. So if there's a particular invoice I want to load, I pass my user in and my ID, and then it'll be able to find the one that matches that criteria and return the DTO for that object. Not the database object. It's not going to return an invoice object, not this file here. It's going to return this file, the invoice DTO. Now, the next line, getAllMine, will only pass in the user and will retrieve every invoice that I own. That's why it's returning a list of DTOs. AddMine will take a DTO that I create from scratch and myself, my user, and it'll add it to the database. And it will return the new ID of that object. UpdateMine will take a DTO that has data I've already retrieved and modified, and it will update the database with that DTO, and then it'll return a copy of it. Delete mine will take my user ID and an ID of a single entity, a single DTO entity, and it'll delete it and then return true or false depending on the success of the deletion. Now, before I actually create an implementation of this generic owned repository, which we're going to have to do, I want to include another library. I want to set up the Automapper library. So let's go to Tools and go to the Package Manager. And I'm going to search for Automapper. This is a very popular library that's used in a lot of projects. And I'll show you how this works. So let's install Automapper. Let's also install this dependency injection library. Okay, so now we know both are installed. Now we want to set this up system-wide so we can use it. So what we have to do is we have to create an object that will store the rules of how we're going to map objects from one to the other. And now you're wondering also probably, what are we mapping? Like, why do we need an Automapper? Well, if we had to copy all of the data out of an invoice class, let's say, into its invoice DTO, we could do it manually. We could create an invoice DTO, and from an invoice, we could then assign from each property the value from the original. So I could assign ID the value from the invoice's ID, and then assign the create date the value from the invoice's create date, the invoice number from the invoice's invoice number, and so on and so forth, one at a time. But that gets tedious. So what we want to do is use the Automapper routine, which will actually copy all of the properties that match from one to another automatically. It's a library used very often with DTOs because we're always copying the columns from one and the properties from one object to another. But we have to set up rules. We have to tell it which objects we want to allow automatic mapping between. So what we're going to do in the repository is we're going to create an object that has those rules. And we're going to call that the Automapper profile. So let's create an object for that. And that uses the Automapper library. So we might as well include that. It's also going to need access to our DTOs and our data folders. So let me include those. Our data folder and our DTOs folder. And what it does is it inherits what's called a profile object, which is part of the Automapper library. So it inherits functionality from that. And what we do is we define a method, actually the constructor. We define the constructor for it, and we put the rules that we want to use in here. So let me put the first one in. It has a method called createMap that we're going to call. And actually, I don't want to do this one first. Let me do the, let me get rid of that one. I want to do the customer first because that's an easier one. So let's create a map between customer objects and customer DTOs. So this is automatic. It's saying if we will have the ability to map a customer object to a customer DTO object, and we give it no rules. So if it's given a customer object and we want to map it to a customer DTO, it'll just go property by property and copy the values from one to the other with the matching names. Nothing difficult there. Now we also create a map to go the other direction. What if we want to copy the DTO into a customer? So that will happen. However, what we're going to do is we're going to add an option to this. And what this says is ignore the ID in the destination. So it will not override the ID in the destination object. This is important because we're going to be setting IDs, and we don't want these to be changed before we apply them to the database. So we have to tell it to ignore the IDs in the mapping from the DTO to the customer. So that'll work for customer. We can do invoice terms, invoice line items similarly. So let me put those in. Same idea. Invoice terms maps directly to invoice terms DTO. The DTO to the regular object is the same, except we ignore the ID. We don't copy that. Invoice line item is the same as well. Now, the invoice is pretty much the same, but there's an additional option. So when we go from the DTO to the invoice, we still ignore the ID. But when we go from the actual invoice, which is the database object, to the DTO, I'm telling it to include these extra two fields. These are fields that don't exist in the invoice object. The invoice object does not have the customer name or the invoice terms name. These are actually available through the navigation properties. So if I had typed, if I had an invoice object and I did a.customer, and then I could get the name from there. So the invoice itself does not have the customer name in it, but it has a customer object that has the name. So I want to take that name out of there and map it back to the DTO field that says customer name. So this is how you can do it automatically. This four-member rule will say in the destination, there's a property called customer name. That is supposed to come from, map from, the source, which is the invoice itself from the database, its customer property dot name. And there's the risk of it being null, so we tell it to ignore that because we're going to actually make sure that's populated. Now the second one is very similar. So for in the destination DTO, where you see this column, this property, take that value from the source invoice terms object name field. So it's able to map the entity object's navigation properties to a flat DTO, because we're not going to put navigation properties in our DTO. We're just going to have a flat object with just a bunch of fields in it. So this is a way to help you flatten it as you transform it from your database to your DTO. So the joining will occur when you do a query and you retrieve an invoice. And then those joined in objects, the customer and the invoice terms, at least one field will be mapped down. You could have as many fields as you want mapped down if you want, but since these only have two useful fields, they only have the name in each one of these. That's the only thing we're concerned about mapping. So that, in effect, flattens the data structure for the invoice DTO. So these are the rules. So how do we tell the system to use these rules? Well, we have to actually add the Automapper profile object into our main program when the entire thing starts up. So let's go back down to the bottom with program.cs, and we'll see in there that we have to do a couple things. So right at the end of here, where we add this authentication state provider, I'm going to add some lines of code. So it can't find this because it doesn't know where to look for it. If I hit Alt-Enter, it's going to load in the repository method package. So it added a using up here for repository because that's where the Automapper profile is. So what this does is it creates a mapper configuration based on this profile. It's just an object that's used by the Automapper routine. So here we are creating a mapper. And this is the object we're going to use everywhere when we want to. And we add it as a service. So there's a singleton, which means it's shared by everybody at all times, which is okay because it's just code that maps C# objects from one to the other. It doesn't take a long time to run. It's not tied to any session. We don't want them created and destroyed a lot. It'll be one of them made in the beginning and used forever. And that's what a singleton is. So that object will exist for the entire life of the program. We can inject it anywhere we want and use it to do mappings between the objects. And I'll show you how we do that soon. Now that our mapper is in place, we're able to go back to our repository and actually implement our generic owned repository. So let me go here and add another class called generic owned repository. And obviously that's going to implement our interface. And we have to actually, this will be a generic class, just like the interface is. So we have to specify that, which maps from an entity, or uses entities and DTOs. So those are the two types we're going to be using. Implements this interface, which also is this, a generic class that has these two types, which also has these rules. So you bring these rules along with you, that the entity object has to know what it is. It has to know it's a class that's an iEntity and an iOwned entity. And the same with the TDTO, has to be an iDTO and an iOwned DTO. So we're ready to go. This is still red because we haven't implemented all the methods yet. As you can see, it says does not implement, does not implement. So we have to actually implement those now. So we can get started. We're going to have a couple properties here. We're going to have a DB context because we need to connect to the database, and we need a Automapper to handle the mapping between our entities and our DTOs. How do we get them? Well, in C# in ASP.NET Core, we use what's called injection. So the way it happens is anytime this repository object is created, you can pass into the constructor the things you'd like to inject. So we want to inject a DB context and we want to inject a mapper. So we make those two things inputs to the constructor. And all we need to do is set the member variables to those variables so that we have those objects injected. So remember, there's one singleton mapper for the entire system. It'll inject that. And then there's a DB context that also gets injected. And then those values will be saved. So let's look at an implementation here of one of the methods. So we'll start. We're going to do all of them, all 5. But the first one we're going to look at is the getAllMine. And it's going to have a corresponding getMyUserID method that I need to show you as well. So let me bring that in. And we'll actually look at that first. So let me put that first. Okay. What getMyUserID is there's this claims principal object that's floating around here. This is the object that represents who is logged in at any given time. So we're going to be passing that into this at some point so that we know who's logged in. And what we can do is we want to find the user ID. So the claims principal is who's logged in. It's usually identified by the username or email. So if you're logged in as a particular user with an email, that is what you would be able to easily access. But on this object, there are also other things. There is what are called claims, hence the claims principal, which are other pieces of information about the user. So not only the person's name, email, etc., their user ID is included. So it's included in a claim that has this name. Now it's a long name. It's a standard name, but it's a long name. And it's called the name identifier. And in ASP.NET Core, this gives you the UID. Now, what is the UID? That is that database user ID for my user. So if I go over here and I show you that, and I go back to here and I look at ASP.NET users, that is this ID column. If I look at the data, you can see that that is this long GUID. So we're going to need to know this GUID because this is the primary key of the object. So this is what we're going to be passing around to know what user is logged in. We don't need the username when it comes to the database. We need this because this is the column that is joined to the other tables. So we need to be able to look that up. So that's what this little utility method does. It gets the user ID based on the logged in user, which we're passing into this. And we're also passing that into all of our other functions, which I showed you in the interface, that claims principal. So here is the implementation of get all mine. In fact, let me put this on a separate line here. Okay. So what is get all mine? It is a asynchronous method, first of all of these are. And again, I want to reiterate, they're asynchronous because we're connecting to a database. When you connect to a database, it can take time. So rather than waiting for it to happen and then return a value, it returns a promise or a task, which the system can go on doing its thing. And then when the task is done, it can come back to it and continue on. So nothing gets held up serving other customers. So here we go. It's to override, we do virtual. And actually not to override, to be able to override, because we're going to override this potentially. We get all mine just means give me all of my objects of whatever object we're talking about. So this is generic. So if this were the invoice version, we'd be getting all the invoices for this particular user. So how do we do that? Well, first we find out the user ID, which is that GUID. If it's not null, which I check, then I do a generic call to the database context. So I create this list of database entities. So if our object was invoice, this would be list invoice entities equals await context.setEntity. Again, if this were for invoices, it'd be context.invoices.where. Now this is the query. So for all of the invoices, where the invoice's user ID is the user ID I retrieved from my claim. Give me a list. That's what toListAsync does. toListAsync actually waits for the database to return the data and creates a list object with those results. So this is generic. This is able to work for any type of database entity, hence this generic type of set based on our entity. So that gets me database objects. But remember, we're not going to give our user of the repository database objects. We're going to give them DTOs. So instead of having to copy everything over manually, we use the Automapper, and that's what this is. So we take our list of we take our entities list, which is this entities object, and we map it to a list of DTOs. So it knows what it's going to copy it to. That's what this generic property is. So all of the entities will be mapped to a list of DTOs, and that's what is assigned to this result on the left. And then we return the result. So if the user ID is not null, it's able to get some data. It may be 0 rows, but if you have no invoices, but it's going to be some result set, 0 or many rows, and that will return. Else, I'm just going to have it return an empty list. So if there just aren't any, or the user ID isn't valid, it'll just return nothing. You may decide to throw an exception here instead, or do some error return. Where you do these things is kind of up to you. I chose not to do that here. But what I just do is return an empty list. So this is good for getting all of a particular entity. Now, what if we want to just get an entity by its ID number? Well, that would be the other method I showed you, which is get mine by ID. It's going to be very similar. So let me put that in as well. Similar idea. It is called get mine by ID this time. Takes the user that's logged in, but also an ID. So if we want to retrieve a particular invoice, we would use this method, and we would pass in the ID of the invoice we want. First thing we do, of course, is figure out who's logged in, get their user ID. If it's not null, we know we're good. And what we do is then retrieve one entity. See, the result is an entity which could be null, hence the question mark. So it could be nothing. It's possible that entity does not exist. And what we do is we call the database contexts set of entities that we're dealing with, which would be, if we're dealing with invoices, this would be invoices, where its ID matches the ID we provided, and its user ID matches the user ID from the claims principal. And then we call this, which is like toList async, but is actually creates one return value, because this is only going to give me one row. So we're not going to return a list. We're only going to return one entity. So this gives me that one entity, or it gives me null if there's no entity there. So if it's an ID that doesn't represent an actual object in the database, then it returns null. So that's what or default means. Or default means or null. Give me the first response that matches, or give me null. And it'll assign it to this one object here. Again, we're going to return one object, but we're not returning the database entity. We're returning the DTO version of it. So we have to create one and map the values from that entity to our resulting DTO, which is what this line does. See, this makes it a lot easier. You don't have to copy them column by column by column. And we're able to make this generic class as well. If we didn't have an automapper, we wouldn't be able to make it generic. We'd have to have rules for each type of class. We'd have to have, like the invoice one would have to be separate, and it would have to copy each thing one at a time. Its ID, then its invoice number, then its description, etc. By having the mapper available, it makes it generic. So we can include it in this generic class that works with every entity and every DTO. And when we make our concrete versions of these, it's going to be so easy because all this functionality is going to just be there for us, and we don't have to write it over and over again. So that handles getting one object. Now let's talk about updating an object. So if we want to update something in our database, we need to have an update function in our generic repository. And here is what it looks like. It's called update mine. And the mine part is who's logged in, so the user that's logged in. And here is the data that we're going to be inputting into it. So remember, the user, when they retrieved an object, they retrieved the DTO version of it. They didn't retrieve the original. So if they make any changes, they're going to give us back that DTO. So first thing we do, find the user ID. And if it's not null, we know we can work with it. That means it's an actual user. The first thing we need to do is load that object out of the database to make changes. So we have to see if it's there. So this is what this does. This toUpdate object is an entity that will be retrieved from the database from the set of objects in the database of that type, where the entity's ID matches the ID in the DTO. So if they're passing a DTO in, it's going to have the original ID of the object they're modifying. So we compare that to the one in the database. And also, of course, make sure our user ID matches. It's good we're checking this user ID in all these functions, because this will guarantee that we're only operating on our objects and not someone else's. This is another layer of security which is being handled in this repository. And we do first or default. Again, this could only return one object, so we return the first object that matches, or null if there is no match. And that's what this is. So if it's not null, we can actually make changes. If it is null, we're going to return null. So if they gave us a DTO, an update for a DTO that didn't exist, we're just going to return null. But if it did exist, we're going to map the other way. So we're going to map from our DTO into the object that we plan to update. This is why I told it to ignore the ID, because I don't want it to overwrite the ID. In case there's a problem with that, I want to make sure the ID in the DTO that we're updating is not modified. So it's going to copy all the fields out of the DTO into the entity that we retrieved from the database. Then what we have to do is tell the database context that this update object has been modified. And then what we do is return a remapping of the DTO back into a result. So we actually return a copy of the DTO that came in with the changes made. And we return that. And we don't actually tell the database to save the changes yet. So this is something I want to mention. If you've used Entity Framework before, you might be noticing this. This modifying of the object that we just did here does not actually modify in the database until you tell the context here to save the changes. That's an actual method call on the context. I'll show you. Save changes or save changes async. We're not calling that yet. We're not going to save our changes until we decide to save all our changes. We may want to make modifications to invoices, invoice line items, maybe a customer, and then all at once save the changes in a sort of transaction. What's called unit of work. So that all of them are applied or none of them are applied, depending on whether it's successful or not. So we don't actually save changes in any of these methods. We're going to have a separate method that we put in a parent object later that's going to let you save all the changes that you've made. So this does not actually update. All this does is change the object that is the version that represents the object in the database, tell it it's been modified, but does not apply those changes to the database at this time. That's going to happen later. But that's what this does. So update mine is complete here. The next function we have to do is the delete. Might as well do delete. And that is very similar to update. It's actually a little simpler because we're not copying any data, we're just kind of deleting. So here's delete. So we're going to pass in, again, our user and the ID of the object we want to delete. So if we look up the user ID, then we can say if it's not null, look for the entity in the database, in that set of entities, where the ID is the ID we provided and the user ID matches our user ID. Give me the first one, or null if it doesn't exist. And that's what this value will have. So if the entity is not null, what it'll do is it will tell it to remove it from the database context. Again, this doesn't actually remove it. It's going to mark it for removal. Later on, we'll tell it to save the changes, but right now it's just going to mark it for removal. So that's what this does. If it didn't find the entity, it'll just return false. And so we know it didn't successfully delete anything. Or if the user ID, isn't found, it'll return that as well. So that's delete. Mark something for deletion. And then the only thing we haven't done is the ability to add one. So to add a object, we have our add mine. So that's going to take as a input, again, the user that's logged in, and a full DTO of all the data in the object you wish to add to the database. First thing we do, again, look up the user ID. If the user ID is not null, we actually set the user ID in the DTO object, because the DTO object, when they're passing this in, the user may not know their user ID. The software may not know it. So to be sure we're doing the right thing, we're going to do that right here. We're going to take the user ID from the claims principal and assign it in that object. Then we're going to take the DTO and add to the ID a new ID. So this is a new GUID from scratch that we're creating. So that's going to be a new ID. Then we're going to make an entity object. So this is going to create a new object that we're going to add to the database, mapped from the DTO object. So because the DTO is complete now, it has an ID, it has the user ID, it has all the data the user wants in it. Map that and create that object. And that's what this does. This map method here actually creates an instance of the tEntity object. And that's the object there. Then we tell the database context, we're in the set of entities, that is the type that we're dealing with, add this to it. So add that, and again, mark it to be added, like get it ready to be added. Don't actually save the database yet, save the changes, just add it. And then so the user knows what ID we created it with, because it's going to want to know. Whoever calls this method is going to want to know what ID this was given, because we have this new ID. Return the ID. So the method will return the ID of the new object that it just created here on this line. So this is it. This is a completely functional set of methods to do CRUD, create, read, update, and delete, of objects. Now, I'm going to add one more method. This last method I'm going to add is going to be kind of a generic query method, because we have two retrieval operations here. We have get all mine and get mine by ID. But what if we want to retrieve objects based on some query criteria? Because sometimes when you're dealing with database, your where clauses can be kind of complicated. You might want a range of data. You might give me all the invoices from a certain date range. These are methods we're going to have to add later if we want to into our invoice, particular classes, our actual concrete implementations of these when we get to it. And we'll do a few of these. We may want to add a method that has extra criteria, like get mine by ID, or get mine between a certain date, etc. So in order to have the functionality ready, I can give myself a little bit of generic code in here that I'll be able to use when I implement my concrete classes. And that method is going to be called generic query. So that's the last method I'm going to implement here. So let me put it at the bottom since it's kind of the last one. It's a generic query. It's going to return a generic list of data transfer objects. It's going to take in a user, but it's also going to take in this expression func t entity bool, which is kind of ugly looking. But this is a long way of saying a where clause in the language in an integrated query, which I'm going to show you how that works. But those are expressions in Entity Framework. Those are what these call. These are like where clauses, can be stored in this object. And it's particular to a type of object. So if this were our invoice, it would be an expression of a func of an invoice. It's a where clause. And we call it expression. The second one we pass in is going to be similar, but it's going to be the includes. And includes are the joins. So this expression is going to represent the where, and the includes is going to represent all of the joins if we want to join in data from other tables. So you'll see how this works when I actually use it. So here we go. First thing we're always doing in our owned entity object is we're checking to see who's logged in, getting their user ID. And if it's not null, we're proceeding. If it's null, we're just going to return an empty list. So what we create is this thing called a query. And this is an iQueryable object of the type of entity we're dealing with. So if it was an invoice, it'd be iQueryable of invoice. Customer would be iQueryable of customer, and our concrete class will fill those in appropriately when we get to them. So the query is going to have, it's going to start off by having a where clause in it of the user ID matching. So we're going to match the user ID. So we're building a where clause in our entity framework one chunk at a time. So our where clause is going to include this, where the user ID is the user ID that's logged in. Then we're going to add to that query our additional expression that we passed in. So we might have done other things like where the date, create date is greater than a month ago. That would be another one that would be here. And that's what would be in this expression object that we passed in. So if that's not null, if the person passed one in, then include that. Then includes is a include, which is join. So include is the equivalent of join in database terms with Entity Framework. So it'll include each of the tables that we wish to include. So in our invoices table, for example, we might want to pull in our customers. We might want to pull in, to retrieve the customer name. We might want to pull in the invoice terms to pull in the name of the invoice term we're dealing with. We could even include the line items if we wanted to. So anytime you have a query that requires you to join data in, this will take those includes from the parameter and include them. And once we have a completely built up query, we can execute it, which this does. It waits for it to return and creates a list. And we'll store that in the list of database entity objects. Then, since we're not giving the user these objects directly, of course, we're going to map them from the list of the entities, or to the list of the entities from this list of, no, to the list of DTOs from a list of entities. This is the list of entities. We're mapping it to a list of DTOs. Then we're returning that result. So this is a pretty complete generic class. There's a lot of functionality in it, which hopefully you'll see very soon why I wanted to put all of this code in a generic class, which might be a little bit hard to understand if you're newer to this and haven't used too much generic classes. But once you see the concrete classes I implement, you're going to understand why I made this generic class. So let's go right into making our concrete classes. And we'll do one of the simple ones first. We'll do the customer table because that's simple. So in repository, I'm going to make a class. I'm actually going to make an interface for it first, which is going to be real easy because there's going to be nothing in it. A customer repository. And that class is actually just going to be the fact that it's going to be implementing the generic owned repository for a customer and customer DTO. And that's it. So an interface definition that inherits another interface doesn't have to implement the interface because it can't, because it's another interface, but it will give it a definition. So it's going to tell us that it's just going to be an interface for the customer repository. That is going to be a concrete class that's implemented based on this generic owned repository we just made for customers and their corresponding customer DTO object. So now we can actually make the real customer repository. So let me do that. Right click, add class customer repository. And this is going to be pretty simple too. It's going to implement a generic owned repository again. Well, it's going to inherit. Okay, let's be clear about this. It's going to inherit from the generic owned repository. So that class that we put all of this great implementation in that I just spent a long time explaining, it's going to get all that functionality, but it's going to get it with all of the types being customer and customer DTO. So it will replace everywhere it sees T entity with customer and everything that it sees T DTO with customer DTO. And of course, this is implementing our iCustomer repository interface. Now, one thing you don't get when you implement an interface or inherit a class is the constructor. You have to make a constructor of your own. So we're going to do that. It's not difficult to make. This customer repository constructor is going to take in the context and the mapper. Why? Because our generic owned repository need those things. So we have to make our own constructor that takes those things and then simply passes them to the base methods constructor. That's why it's implementing or inheriting from the base constructor context comma mapper. So it's going to take context comma mapper and it's going to pass it back into our this object here. It's going to pass it all in there so it has access to it. That would be enough. This technically is enough to now utilize the customer repository. This is going to have get all mine, get mine by ID, update, add, and delete. I'm going to add some customization to this a little bit later, but I want to leave it as is now so you're able to see how this works. So let's go ahead and make our invoice terms repository as well. So that should be very similar. So let me add class here, invoice terms repository. That's going to be a generic class. Well, it's an interface that extends the generic I-own generic repository for the invoice terms. And actually, it's not a class. It's going to be interface. invoice terms repository. That's done. Let me add a actual implementation of that, which will be called invoice terms repository. And that's going to be a very similar implementation as well, which I'll just paste in because it is the same thing. Again, it just extends the generic owned repository implementation with mapped for our invoice terms to invoice terms DTO, and implements the invoice terms repository, and needs to have a closing curly brace. So that is the implementation of the invoice terms repository. We're going to add a little bit to this later too, but for now we can keep going. Let's do the invoice repository. So let's add a class for that, which will be an interface, invoice repository, which will also be very simple. Implements the generic owned repository interface for invoices mapped to invoice DTOs. Let's do the concrete version of that. Invoice repository, which is going to implement that. So it is the inheriting of our concrete implementation of the generic owned repository with these types and the interface, overriding the constructor and passing the DB context and mappers into the base implementation. So that's handled invoice. Now we just need to handle invoice line items. So let's do add a class for, or an interface for invoice line items, or invoice line item repository. Which is going to look like this. Again, very similar, just mapping the generic owned repository to these types. And I will create the concrete class as well. Invoice line item repository. And that is going to look like this, with some additions later, but I'm keeping it simple for now. Again, so these are all really identical. We have the invoice line item, invoice customer, and invoice terms repositories that are all inherited from the generic owned, mapped to their appropriate types. Now what I'm going to do next is group these repositories together into a master repository collection object, because we're not going to want to pass around all these different repositories. We don't want to have to retrieve an object for each of them. So we want to have one object that contains all of our repositories. So I'm going to call that a repository collection, and I'll make an interface for that as well. It'll be an interface. And it's going to be very simple. It's going to have all of our repositories as members, member properties. So we could get our invoice repository, our customer repository, our invoice terms repository, our line item repository, or we can save. This is what I was talking about before, how if we make any changes to any of these tables, at some point we're going to want to save the changes. So we're going to implement that saving functionality here in this repository collection. And this is going to be something that implements iDisposable, because we want to make sure that we take care of cleaning up our database collection, or our database context, if it gets disposed. So that's our repository collection interface. Let me make a concrete class for this. .cs. That is going to implement the interface we just did. It's going to be creating our interface. It's going to be creating our repositories. So it's going to need the database context and the Automapper that each of our database repositories need to use. So we're going to include them. The only way to get them is to inject them. So we're going to inject them into this object. Which is going to take a application DDB context factory and a mapper. So it's going to assign those. Now, it's also going to have those 4 properties that are the actual repositories. So it has the repositories will belong to this class as members. When we first construct the object, we're going to initialize those. So we're going to make a new invoice repository, customer invoice terms and line item repository, passing in these contexts and mappers that we just got from being injected. Then we need to implement that dispose method I talked about because of just being disposable. And what I'll do is I'll just dispose of my context. This is my database context. If the object needs to be disposed, it'll take care of that. Now, the last thing it needs to do, which is the trickiest thing, is actually save the changes. So let's see how I did this. Let me paste it in. And we're going to have to add a few objects to it, but that's easy. So what save does is it really is simple. What it does is it tries to return our database context saving the changes. So any change that's been made in any of the repositories will be saved to the database at that point. But the problem is something could go wrong. So this is where we're going to handle any of the exceptions that occur. So the first kind of exception that can occur is a DB update exception. And what this will do is I can actually retrieve the entities that are in that exception. And what I can do is create a repository update exception if this happens. But what I also do is if it happens to be an object that was modified, I go in and I change the values back to their original values and say that it's unchanged. So I undo the changes that were going to be done to the object. And I throw this exception. Now, it doesn't exist, so I'll make it. In fact, I could use the quick, I won't use the quick implementation. I could have it make one quickly, but I'll just make them soon. If it's a deleted object, I tell it to not delete and then throw a delete exception. If it's added, then I just tell it to throw an add exception. So we know what kind of error occurs based on what error is returned from the database. So that'll give the calling program a little bit of guidance as to what happens. And you'll see how we use this later. But I need to make repository update, delete, and add exceptions. These are not tricky objects. They just extend exception. So I'll just add them real quick. We'll call this repository add exception, which will extend exception. We'll do the repository update exception. Which will also extend exception, and then we'll add the repository delete exception. Which will also extend exception. So now we can send a little better information back to the caller as to what happened. And we could extend this later too if we wanted to provide even more detail now that we have these exceptions. But for now, this will do. Now that we have a repository collection object, I want to create a service out of it. I want to make sure I can inject this into any of my Blazor pages that I want to use. So let me go down to the program.cs. And right here, after I added my mapper, or maybe before, let me put in this. So I'm adding a transient service that is my repository. So this every time the site is called and needs to contact the database for objects, or go to this repository, it'll create a new object. That's why it's transient. And it'll get a DB connection from the DB context factory, and it'll get the one version of the mapper that's running as a singleton. And then I'll be able to inject it wherever I need to use it. So let's go ahead and actually use it. And I'll go back to the page that I said I didn't like the code on, which was my index page, because I was using the database directly here, contacting the database and loading the customers. Let's just do the same thing using the DB context now. Well, not the DB context. We'll actually use the repository. So let's go up here, and instead of injecting the DB context factory, I'm going to inject the repository collection. And I'll call it repo. Now, it needs to know where that is. So rather than putting the using in here, I'm once again going to put it down here in my imports. So that's available to every page, because I don't want to dirty up my pages with all these imports. And I think I'm going to need the DTOs as well. So let's do DTOs. Okay. So back here, we have our repo. Our list of customers is no longer going to be a list of customers. It's going to be a list of customer DTO objects. And we're not going to need to create a DB factory because we're not doing that. All I need to do is have my repo connect to my repo has a customer method, and I can say get all mine, and then I just have to pass in the user principal. But how do I know who's logged in? Where do I get that claims principal object that I talked about before? Well, in order to do that, I just have to go and inject another service. It's called the authentication state provider. So if I go up here and I inject that, it's called auth state. All I need to do is use that service, that state provider, first, and that will give me my authentication state. So it'll tell me who's logged in at the given time. And I'll say auth.user. That is the actual user that's logged in. So that is the claims principal. See how it's a claims principal object? That is the user that's logged in currently. Now, if there's no logged in user, this isn't going to work. But that's okay, because if there's no logged in user, my get all mine should return nothing. So it should just have no customers. So that's okay. This is a secure method. It's not going to show data that doesn't apply to someone who doesn't exist. So this should be okay to leave. Now, if I come up here, I broke my for each because these are not customer objects anymore. They're customer DTO objects. Remember, again, I'm not working directly with my database objects. I'm working with these copies, which are called DTOs. So now we have no idea that we have entity framework in this program. We have no idea there's a database. All we have is a repo, a repository, that deals with customer data transfer objects. So it has no idea that there's a database. Let's go ahead and run this and see how it works. It should do the same thing our other example did, just retrieve the customers. And maybe it did. It's not showing any, but we're also not logged in. So that could be what happened. So let's actually log in. Lo and behold, there they are. So the repository was able to retrieve my 3 customer DTOs and display them on this page. Okay, we're not really done with our repository objects yet because there's some special functionality I want to add to each one of them. Let's look at the customers one first and discuss that. So the customer repository has its 5 methods where we can add, retrieve, update, and delete customers. But I want to add another method. I want to add a method that will handle seeding initial data, because when the person first logs into the website, we might want to actually create a sample customer for them, because it could cause problems in the functionality that I know about later that I will get to, that having at least one customer in the database for every user that signs in is good. So what I'm going to do is actually add another method to the customer repository in addition to the ones that are inherited from this generic one. And I'm going to call it seed. So it's going to seed data. Let me go to the interface for this, and I'll add a method in the interface called seed, which is going to take in the user that's logged in, so we know which user we're seeding data for. And then in the customer repository concrete class, I will add the method seed. So what this is going to do is look up the user that's logged in. If it's not null, find out how many users or how many customers this user has. That's what this does. It does a where the user ID matches the user ID, and it counts. So it calls the SQL aggregate function for counting, and will count how many rows would be in the query. If there are 0, it will create a customer DTO with a name of my first customer, add it to the database, and actually save the changes right away. We don't have to save the changes right away. I'm actually going to change that. That's something we can call our save method on the entire repository collection for it to handle. So this will add the customers to the database and be ready to save when we call save on our repository collection. So this is good for customer. I want to do something similar for the invoice terms. So let's go to the invoice terms repository interface, and I will add a similar seed method. And then in the concrete implementation, which is here, did I do this wrong? I did this wrong. This shouldn't be in the invoice. It should be in the invoice terms. Invoice terms repository. We'll have a seed. And in the invoice terms repository concrete class, I will put in my seed method. It's very similar. What it does is, okay, there's an error here. If I go back to the invoice terms repository interface, it's there, here. It's not an override, it's an implementation. So we implement the seed method, which similarly will look to see if the user ID exists. If it's not null, it's going to count how many invoice terms are already in the database for that user. If there are, and that's where this count async comes in, if there's 0, it'll create 3 new terms, a net 30, 60, and 90, and add the 3 to the database. So now these invoice terms and customer repositories have these seeding methods now that let us seed default data. We're not going to need to do that with any of our other objects, but there's some other customizations we'll do on the invoice object next. So let's load the invoice repository interface. We're going to add 2 methods to this. We're going to add a method called getAllMineFlat and delete with line items. GetAllMineFlat is going to retrieve the invoices for a particular user, all of the invoices, but it's going to join in the customer and invoice terms data to include that data in the flat invoice DTO. Our generic owned repository doesn't know how to do that because it doesn't know anything particular about the invoice or the invoice DTO. So this is where we're putting that extra functionality that's going to do the join to join the data in and include it in this one invoice DTO object. So that we're going to do that. And then delete with line items is actually going to let us delete an invoice ID, but it'll not just delete the invoice ID, but all of the line items that correspond to that invoice ID as well. So let's look at those implementations. So we'll add those to the invoice repository object, which again has nothing implemented yet because it's just a version of the generic owned repository. So the first method we'll look at is delete with line items. So let me paste that in. Delete with line items takes in the user and the invoice ID. Again, we look up our user ID, and then what we do is we retrieve all of the line items from the database where the invoice ID matches and the user ID matches. So that'll be a list that it'll retrieve. So if the invoice has any line items, this list is going to have them. So what do? We iterate through the list, and this is a list of invoice line item objects. We iterate through it, and for each one, we, in the context object, remove that particular line item. So that's going to mark it for removal. We won't actually remove them again. Remember, that won't happen until we hit save in the entire collection. And then once we've removed all the line items, we find the invoice itself. So this is the invoice object where we go to the invoices table in the entity framework context, where the ID matches and the user ID matches. Give me the first one that matches or null if nothing matches. So if it's not null, we tell it to remove or mark for removal that particular invoice. So that's what this delete with line items will do. It's smart enough to go and get rid of all the sub line items for an invoice so that you can completely delete the invoice. If you didn't do this, it wouldn't let you delete the invoice because there'd still be line items that refer to it. And remember a while ago I told you I removed deleting cascade. So I want to protect referential integrity, so it won't let you do that delete unless you went ahead and deleted the invoice line items first and then delete the invoice. So that's what this method takes care of. Now the getAllMineFlat is another method, and this is kind of like getAllMine, but it's a little more kind of manually done because we're joining in data from 2 other tables and injecting it into this invoice DTO. So the way this works is we first get our user ID, which we always do, retrieve from the invoice table where our user ID matches. And here is where we include. So we include the line items we include the terms, and we include the customers. So this is including all the data. And what we can do is we then populate all of this data. So the ID is a one-to-one match. That's easy. The create date. Now notice, this is what the Automapper is usually doing. But since we're doing a little more specific logic to the invoice table, we can't use the Automapper here. So we do ID, we do create date, invoice number, description. Here we pulled in the customer name. So see how the customer name is actually referring to the customer object as part of the invoice's name property. So that is this flattening that's happening here. Same with invoice terms. It's the invoice terms navigation property, the name property on that. Paid, credit, tax rate, user ID are all the same. Invoice total is interesting because now we included all the invoice line items. So all the invoice line items for that invoice were included. We can use the aggregate function sum to sum up the total price of all of the line items to come up with a total, an invoice total. This is not something that we had before. This is something that is calculated based on the line items. So we're able to aggregate these line items together and put that total also in this invoice DTO object. So we do that for all of the invoices, and that becomes the result of the query, which we execute as a list and return the results. So anytime you need to do any special queries where you're joining in extra data into a DTO perhaps that has extra fields in it, you have to do it manually because we're doing additional logic, especially the sum. This is strange. So this is something that the Automapper could never figure out. So, but notice we've saved having to do like at least a dozen mappings like this using the Automapper and using the generic repository object. So this is still not much redundant code. So that's it for invoices. Now the invoice line item repository is going to have another special method on it. And there's just one of them, and it's going to be, here, I'll show you. We're going to add a method called getAllByInvoiceID. So if we want to just retrieve all of the line items for a particular invoice ID, that's something that we don't have in our generic owned repository. We have getAll and getOne by its own ID. We can't get all of the line items for a particular invoice ID. So that's going to be a custom query. And it's not going to be complicated to implement because we made that generic query in the generic owned repository. So you're going to see now finally where that comes in handy. So let me go into the concrete class and implement that method. In fact, it's only one line of code. And it's basically get all of my line items for a particular invoice ID. And all it needed to do was call the generic query in my generic owned repository, pass in the user, pass in the where clause. So this is an additional where the invoice ID is the invoice ID that I'm providing. And then null means don't include any other data. So I'm not going to join this with any tables. So that alone does the job. So if you need to add queries that have a little more to their where clause, this is how you do it. You can use the generic query that I implemented in generic owned repository. So that's all of the functionality we're going to need in our application for our repository at this point. Hopefully you can see how it provides basic CRUD functionality to any objects you have. And yet, in addition, you can customize each one a little bit to provide a little bit more customization as far as what data is retrieved or what happens, seeding data, etc. You can put some more of the logic of your application in here. Now that we have a database set up and we have a repository that allows us to interact with the database, let's work on the user interface finally. So what we're going to be doing is we're going to be using Blazor built-in components, but we're also going to be using a library from Radzen. Radzen is a company that provides Blazor components, and we're going to be using some of their components. They have a particularly good data grid component, which I'd like to demonstrate. It's a pretty common component you'll end up using in a lot of applications that require data manipulation. It provides a table interface into a database table or a series of records. And it's not something you'd want to code from scratch, so it's something you'd want to use from a third-party vendor. Radzen allows you to use these in your project, and we're going to go ahead and install that. So if I go to Tools, go to Manage NuGet Packages for Solution, and under Browse, search for Radzen. And all you have to do is install the Radzen Blazor package. Now there's some preliminary setup we have to do to integrate it into our project. The first thing we want to do is we want to go over to in the Pages folder, this host CS.html. I remember in the beginning of this tutorial, I mentioned how this is sort of the main page that's loaded. And then the Blazor Server is executed out of this page. So if you wanted to add any style sheets or anything, or JavaScript to your page, this is where you would do it. So this is what we need to do. First of all, there's a style sheet that Blazor uses for its theming of its components. So we're going to put a link to that. And then what we have to do is include some JavaScript for Radzen here at the bottom. And we can just place it right underneath the link to the Blazor Server JavaScript. The first page I'd like to work on is the page that will allow the user to add, remove, and modify the customers that they have in their account. So I'm going to go over to the Pages section here, and currently we only have one Blazor page. It's the index page. I'm going to right-click and add a new Razor component. I'm going to call this Customers, or maybe Customer Setup. So right now this is a page that's not navigable. In other words, there's no link to it. So what we have to do is put a page directive at the top to say where what URL we use to get here. So I'm going to do /customer setup. And right now there's just a header and there's code but with nothing in it. So this is just a very basic Blazor page. Now, while I'm here, I might as well add the page for setting up the invoice terms. So I'll do that as well. We'll come back and fill it in later. So I'll call it invoice terms setup.razor. And similarly, it will have a page directive of invoice terms setup. And the home page is where we'll actually list all of the invoices that the person has. So we'll leave that for last. So let's look at the customer setup page again. Now we need a way to get here. So we have to modify the menu on the left to link to this customer setup. So that is actually located still back in the shared folder. And there's this nav menu.razor that we showed before. So right now it has a link to home and a counter and fetch data. Well, we're not going to use the counter and the fetch data because they're gone. So I'm going to change this to be the customer setup. So we'll call this customer setup. And under the URL, I'll say customer setup. And as long as this matches the URL here, it will link to that page. Now I might as well make this one the invoice terms setup. And then I will do invoice terms setup as the URL. And as long as that matches this, we're good to go. So let me just run this real quick to make sure that these changes work. And you can see we have now our home page and a customer setup and an invoice term setup. So our navigation works to these multiple pages here. Now all we have to do is implement the content for that page. So let me close this. Now what I'm going to do is, rather than implement the content right in this customer setup page, I'm going to create another component that I'm going to embed in this page that's going to have the functionality of setting up customers. So to do that, I'm going to create a subfolder in my pages called components. So let me add a folder here called components. And I'm going to add in there another component called the customer setup component. And we'll get to that in a minute, how to actually implement that. But let me go back to the customer setup page for a second. We only want this to work if someone is logged in. So if they're not logged in, we want to show them like a message saying you're not logged in. You can't set up your customers. So there's this Blazor component called an authorized view. And what I can do is I can insert that. So what I can do is actually put a page title in here. And the page title is going to be customer setup. So that's what's going to go on the top of the page in the tab in the browser. And if they're authorized, in here we're going to put this component we just made, which is our customer setup component. Now you can see it auto-completed with this large namespace in front of it. That's because it doesn't have the using for this sub area here. So I'm actually going to go down and in the imports include that. So what that was is, let me go back, and this was the using I need. So I'm going to go back here and stick this in here. So now we have a full including of that in all the pages. So if I come back here, I can remove this and just put that. So this is the tag that represents that here, if they're logged in, we're going to show the customer setup component. And in here, I'll say, please log in to see your customers. So if you're not logged in, you're not going to see customers. So let's run that and see if that works. I click this, and yep, it's telling me I need to log in. So it'll show me the page, but it will tell me I need to log in to see the customers. Okay, so now let's work on this customer setup component. This is where the real interesting work is going to be done to work with our customers. So let me go in the customer setup component. First thing we need to include in this component are the two services that are required for us to work here. And the first is our repo that we made, our repository. And the second is the authentication state provider. So now we can know who logged in. And then once we know who's logged in, we can access our data. So these two objects we need to inject into the page. Before we go any further, I want to actually go in and delete the data that I did in my test data. So let me go to View, SQL Server Object Explorer. And in this customer table here, we have, if I show data, we created 3 dummy customers. So what I'm going to do is actually just delete these, because we want to test the feature of seeding the data if there is no data. So let's leave it blank to start. Close that. Okay, so we're back here. Now, for the object for this component, we need to have a couple properties. So the first property we're going to have is a list of the customers, because we're going to be retrieving this list as a list of customer DTO objects from our repository. So we'll put that there. Now, we also need to actually load the customers. So I'm going to create an override of the onInitialize async. This method will run as soon as the component is loaded the first time. And then it will retrieve the authentication state from our authentication state provider. And then it will assign to the customer's variable the result of calling our repositories customer getAllMine method, passing in the user. Now, if I do this, remember, it's possible that there are no customers because it's a new user to the system. So this could just produce no data. So I want to actually seed data here. So what we have to do is call repo.customer.seed, pass the user in. And we have to await that because, again, that's an asynchronous method. And then before I try to get my customers, I want to actually save the changes from seeding. So let me do that as well. So let me await repo.save. So that's going to save my seed. Now the seed is only going to put one row of data in if there is no data. So we can call this every time. It's going to check every time, but that's okay. If there's no data, it'll put it in. If there is data, it'll just leave what's there. So if at any point the user deletes all of their customers, it's going to put another one in. So they never have no customers. And you'll see how this works. So this is really the beginning of what you need to tie your data to the user interface. Now up here, if we didn't have anything like a fancy component, we could loop through this customers array or list and display a table of the customers or display whatever HTML we would like to. But since we're going to do some interactive editing, we want to have a data grid that'll actually let us edit inside the table itself, like in line, in the row. And that's something that is a little difficult to code. So it's not something you want to code from scratch. So we're going to end up using the Radzen components for that. So let's include the Radzen libraries actually in our shared imports file. So let me go back to imports. And let me also import Radzen. And another Radzen.Blazor. So now that we have these two things included, we're going to have access to the Radzen components. So let's start building that. The first component we're going to use is the Radzen data grid. This is what I was mentioning before. It's a tabular representation of the data, but it's an interactive grid. It has the ability to not only display data, but allow you to edit it inline. So it's going to have some properties here that I'm going to put in. This is the beginning of using it, so we're going to add to this. But here's a thing, allow alternating rows. This is if you wanted to have each row having a different style, but we're going to have every row have the same style, so that's going to be false. We're going to allow sorting, so this is another good feature of this grid is you can sort the columns. We're going to have editing, but it's going to be editing mode single. This is a feature of this data grid that lets you edit one row at a time. The data tells you what object the data is coming from. In this case, it's our customers. And you have to know what the type of each item is. In our case, we're dealing with customer DTO objects. So the next thing we want to do is start explaining to it which columns we want to show. So there's a subcategory, a subtag here called columns. And we can define these columns in a fairly simple way, or we can provide templates for how we want to show the data in each column. I'm going to start by only putting one column in. So here is a Radzen data grid column tag, and I'll close it. So this is one column. It's telling you that you're using the customer DTO object for this column, and we're going to retrieve the property name from it. We're going to give the title of the column name, and we're going to say how wide it is. Now we could also show the ID if we'd like, so I'm going to do that. So let me make a copy, and I will put ID here because ID is a property of the customer DTO, and I'll make the title ID. Now, I don't want to go too much further before we start using this so you can see how it works. So this should be 2 columns, and it should be a grid. So let's see if this actually works. So I'll go up to the top and run it. Now, if I go to customer setup, you'll still see, please log in to see your customers. So let me actually go and log in with the user account I created before. And if I go to customer setup, here we go. We've got our table. We have an ID column and we have a name column. Now notice there is one record. It's my first customer. So that seed method I called worked. There were no customers, so it went ahead and created a customer and put it in the table. So this is a beginning. We have the ability to view the customers now that the user has. Let me close this up. Now let's let the user edit. So let's let them actually edit the name of the customer. So we're going to have to make it so each row has the ability to turn on editing and save the changes. So there's a couple things we need to do. First of all, in the main Radzen data grid tag, we have to add a row update attribute. So I'll do that. And what this is going to do is actually tie the updating of the row to a method that we're going to implement later. So you can see it's underlined in red now because I haven't coded it yet. This will occur whenever the user says they're done updating a row, or they wish to update a row. So the next thing we need to do is we need to explain to the data grid how to show the user the edited version of the row. So if we want to edit the row with the name in it, we would want a text box to pop up that would have the name in it that we could then change. So the way you do that is in the column itself, there is an option for what's called an edit template. So I'm going to copy my edit template in here. And this is how this works. What we have here is an edit template, and the edit template is what will show up in that particular row in that particular cell. And what you do is you create a context. So the context is going to give a name to the actual particular customer that you're dealing with in that row at the time that you're editing it. So if you're dealing with one of your 20 customers or something, the row that this is currently on and being edited will have the variable for that row, for that customer DTO, in this variable name called customer, only in here, inside the edit template. So what we put in the edit template are a couple things. This is a Radzen text box. This is another component from Radzen, which is just an editable text field. And what we do here is bind to it the value of customer.name. So whatever variable is in customer.name, or whatever value is in the customer.name variable, will be populated in the text box. And you can also add a validator. So this is going to say a name is required if we don't put a name in. And that's what this Radzen required validator is for. And it refers back to the component called name, which we named here with this attribute of the Radzen text box. Now, we're never actually going to see this editing because there's no like button to click to enable editing on this row. So in order to do that, we actually have to add another column with some buttons in it. So that's what I'm going to show next. And this is going to have quite a lot of things in it because it's going to handle buttons for editing and deleting and saving changes and etc. So let me put it in first and then I'll explain how it works. So right here after this column, I'm going to put another column. So yes, this is the whole thing right here. And it currently has an issue because it's calling some methods that don't exist yet. There's an edit row, there's a delete row, save row, and a cancel edit, which I have not implemented yet. So we'll get to that. These are all methods that are required for you to implement to make this function work. And we're going to do that. So in any data grid column in Radzen, you have two templates. You have the template for what it looks like when the row is not being edited, and the template for when it is being edited. So for our first column up here, we didn't bother having templates because it just shows the ID no matter what. In the second, we have the name column. So if it's showing, if we're not editing it, we're just showing the value of the name. But if we are editing it, we use the edit template. Now this third column here has a template for when it's not being edited and when it is being edited. So the not being edited one is going to has a button here that will actually enable editing, which kind of makes sense. It's a button. It has an icon and some styling options here. And when you click it, it calls the edit row method, and that's going to actually turn on editing for that row. And we're going to see how that works in a minute. And then this on click stop propagation equals true is just something that's recommended you put in from Blazor, Radzen, actually from Radzen. The next button is delete. So we're going to be able to edit or delete. Those are going to be the two options. And that we'll call the delete row. Now, if we call any of those, it's going to change to the edit template version, which is going to actually enable the text editor up here, because this row will be edited, and it'll provide a check, a close, and a delete button. So the check button will be to confirm your changes, the close button will be to cancel your changes, and then delete will go ahead and delete. So that's going to correspondingly call save row, cancel edit, and delete row. So to make all this work, we have to actually include those methods. So let me show you what they look like. First of all, we're required to keep two objects down here. We have to keep track of customers that are about to be inserted in our database and customers that have to be updated. And this is a requirement of the Radzen data grid again. Insert we're going to deal with in a minute, but update we're going to deal with right away. So we keep track of these two variables. The first one I want to deal with is edit row. So we're going to have a method here called edit row. I'll put it here. Now there's a couple things that are broken here. Let me explain what this is. I want to add a variable to this program that lets me store a message that I can show to the user in case I have to alert them to something. So I'm going to create a empty string up here to store a message, and then I want to display it above the grid. So to display it, I just have to reference it. So I'm going to go above the data grid, and I'm going to include a div that shows that message. And text danger will just make it look like an alert message. That's the style of that div. And while I'm here, I'm actually going to add another option to the main Radzen data grid. There's this reset option that we want to do when we try to sort if we do a sort, and that's just something they recommend to do as well. So there's going to be a function called reset that we bring in. So let's go down. So we have that. Now another thing we want to do though is we want to keep a reference to the actual component object. So when you create an object on a page, there is a class for this, the Radzen data grid class, that will create an object that you can reference in your code. So what I did is I put this @ref equals, and you can do this for any Blazor component. So it'll look for a property in your class called customers grid, and it will make that the object that refers to this grid that's up here. Now I didn't make it yet, so it's red. So let me go down and actually put it in. And that's really just a Radzen data grid of type customer DTO. And that's the name I gave it. So now that's going to be happy. So let's look at edit row. So whenever we check the button to edit a row, it's going to clear the message out. So if there's any errors or anything, it'll just clear them. It'll say that we're going to update this particular customer. Should probably use singular on that. So the customer that we're going to edit will be this particular customer. So we store it in the customer that we're going to update. Then we can call the customer grid edit row method. So that's why we needed the reference to the grid, because there's a function called edit row in the grid itself, and that turns on editing for that row. This is all from examples on Radzen's website. So if you want to read more about it, just check out their website, and they have full documentation on how this works. So that's what happens when we edit a row. We check the edit row button. This turns on editing for that row. Then we have this coupling of updating and saving row, on update and on save. Let me paste those in. So, and we're going to need reset at this point because it's asking for it. So what does update row do? What update row does is it will pass in the customer once the user has checked that they're okay with the changes. So the values will be updated in the customer DTO, whatever they changed. So that means we can go to the database and actually save the changes. Now we don't do that directly, we do it through our repository. So I get the currently logged in user, I reset. Again, this is recommended by Blazor. What that does is clears out and nullifies these two customers, the ones we're inserting, ones we're updating, which makes sense because we're already updating it. We want to say if we're done, so we clear it out. We're not updating it anymore. And then what we do is we call our update mine method. So it'll actually take that customer and update it in the repository, and then we save the changes right away. So that'll save to the database whatever changes we made on that row. Now what this does, save row, is just the kind of turning on of the updating for that row, triggering the update. So that's going to call with the customer variable and pass that in to update row on the grid. And that's linked up. So on update row and save row and edit row are all methods that are required up here. Save row is here. On update row is referenced up here. This is a main method that is tied to the entire data grid as a whole. The buttons, however, are triggered with different methods. Like save row is a different method, and so is edit row. That's triggered just by these button clicks. So clearly we still need a few more. We need a delete row, cancel edit, and cancel edit. So let's go down and add those as well. Cancel edit is an easy one, because all it does is just kind of get you out of the mode of editing, because we don't want to save any changes. So it just passes in again the DTO of the row we're on. We can reset to set those variables to null, and then cancel editing. So it'll take it out of edit mode and display it back as a normal row, not being edited. That's what this will do. So now let's look at delete row, because that's a little bit more involved. So here's delete row. Again, it's going to pass in a customer DTO. And so what can we do? When we get to this point, we know that the user is going to want to delete this customer. So we find out who's logged in. Again, reset our objects. And then we actually call the delete method on our repo, passing in the customer ID and the user. And it's going to return whether it even found it to delete it. So if it found it, we go ahead and save that change. And once we save that change, we can then reload all of my customer objects. Now, there is a problem here, because what if I delete the last thing in the table? I want to make sure it'll then go ahead and add it again, the default one. So I'm going to actually copy from down from the initialization this seeding option. So what we'll do is if it deletes it, that's when it's going to delete. So that's when it's actually going to save the changes. So then I'm going to run this real quick right after. Seed it. So if there's nothing in the database, add it and save it again. So if they deleted the last thing, it'll put another example customer in. Then I retrieve them all, which is going to reload the this variable up with the data from the database. And then I can tell the grid to reload itself. So that's going to have it refresh itself with this new data. Now, if I didn't find it, I'm just going to have the grid cancel editing of that row entirely, and then just reload the grid completely. Now, we could also get an exception. And the exception is going to occur mainly because you won't be able to delete a customer that's being referred to by an active invoice. That's an exception that'll occur. It'll be a SQL exception. The database will literally not let it happen. So if that does happen, I'm going to put a message at the top saying, you can't delete that customer. It's being used by an invoice. Just so we know that there's a reason why it didn't delete, because they might keep trying to click delete and it doesn't do anything, and they'll want to know why. So this will actually catch that exception and show them why. In fact, if we didn't catch the exception, it would just crash the program if they tried to delete a customer that has an invoice that refers to it. So we do catch it, and we put the proper message out saying, you just can't do this because it's being used by somebody. We're not going to have that problem right away because we don't have any invoices. So, but it's there for when we're ready to do it. Okay. Finally, we want to add the ability to add a new row. So what I'm going to do is actually put a button above the grid entirely. And this is going to be a button that lets us add a new customer. So I'm going to use another Radzen button. And it's called Radzen button. It has a text of add new customer. It needs a method called insert row, which we're going to add. And we're going to allow it to be disabled. So if any of these are in progress, like we're trying to insert or update another row, we're going to disable the add new customer button. We don't want that to conflict. We want them to handle their editing before they try to add a new row. So that's another reason to have these variables. It keeps the state of the what's going on with the data grid kind of intact. So this allows us to disable this button if any of those are true. So what I'll do is I'll implement insert row, but we also have to tell the data grid how to actually create a row. And that is going to be another method on another property to the Radzen data grid in general called row create. So there'll be another method called onCreateRow. So let me go down and actually implement those two. And here's what they look like. So we have insert row will create a brand new customer and simply insert a row in the grid with that customer and clear any message. It clears the message in case there was an error from before. Like if we had an error like can't delete the customer, we clear that. So that now, because we're now onto a new task and we want to make sure that error doesn't hang around forever. So that's what we do, we clear that. And then once we actually add it, this is called. So what it'll do is it'll pass in this customer, the new object that's created, and we find out who's logged in. Then we set the ID, or we can retrieve the ID of the person that's created as a response from our add mine method that we created. So when we add mine, we're calling the customer DTO with all the data in it. And then we hit save, so that applies it to the database. And then we can reload everything from the database. So all of the customers that are ours, we reload, because now it's going to have that additional customer in it. And that will update the data grid. And then we clear out this customer to insert variable, because we're done doing that. So let's see if all of this works. So let me run it. And if I go to customer setup, again, I'm not logged in, so let me log in. And I'll go back to customer setup. Okay, so now you can see there is a third column here with a little pencil and a delete. So if I click the pencil, you can see what that does is change the options over here to a checkbox, an X, and a delete. So I can change the name of the customer. So let me just say like Microsoft. And then when I hit check, it's going to trigger our code that's going to update the database. So if I hit check, notice it went back to non-editing mode. So I have my pencil and delete button again. And notice my button actually, my add new customer is enabled again. So while I was editing it, it disabled it. And then when it was done, it re-enabled. Now, did this actually work? Let me go into the SQL Explorer here and load up the data here. Well, there it is, see? So that's Microsoft. Now, I don't think our user wants to see these IDs, so I'm going to remove that column from our Radzen data grid. So let me go into up here and just take this out completely, this first column. Now when they run it, they won't see it. So let me log in again. Go to customer setup, and you can see now it's nicer. It's just Microsoft and nothing. If I edit this, I can change it to, let's say, Tesla. Now, if I want to delete it, or let me not delete yet, let me add another one. So let me add a new customer. And notice what it does is it created a new customer, added it to the table, but it made it blank. We haven't actually entered anything yet. If I try to save it, that little validator I mentioned comes up. So it says name is required. So let me give it a name. I'll put Microsoft back in. And then when I hit check, now I have a table with both of these things in it. So I can sort this as well if I'd like. So I can use this little arrow here to sort. Now if I want to delete, I just go to the delete over here and it just takes it away. There's no confirmation. You could pop up a dialog that says, are you sure you want to delete? But we didn't do that. Now, if I go ahead and delete this, notice it goes away, but then I called reseed, so it added this my first customer. So it's never going to let you have no customers. So I could edit this again and change it back to my Microsoft. All right, now if I edit this and hit delete, notice it deletes it. So the delete option is available even in edit mode as well. And then it re-added, obviously, the my first customer again. So we can do this, add a new customer. Etc. So now we have a working editable table that lets us modify our customers. Now I don't like this because that's the default. Let me change that to just customer setup, or even just customers. So that's probably right up here in this header. Yeah, so let me just change this to customers. Now let's do invoice terms, because that's going to be pretty much identical. So I might skip ahead in this once we get to the point where we implement it. So let me go to the components here, and we have a customer setup component. So let me add a invoice terms setup component. Okay, and it's going to be almost identical to the customer setup one. It's just instead of using the customers, everything that's customer will be invoice terms. So I'm going to literally just copy all of this into the invoice terms setup component and just change the names of everything. And then here we'll do like we did here. So I'll copy this customer setup from the customer setup page to invoice terms setup. And I will include the invoice terms setup component. And please log in to see your invoice terms. And make this invoice terms. The only thing left to do then is to make the invoice terms setup component, which is going to be exactly, again, like the customer's setup component. So let me pause the video and do that real quick. Okay, so here I am back on the invoice terms component, and it's literally the same thing. Just everywhere you see invoice terms is what used to be customers. Because the two tables are practically identical, we're just editing the name of the invoice terms. And this would actually be a good starting point. So this is something you don't have to write from scratch. Even if your table had a couple more columns in it, you could pretty much use all of this code over again and just change the name of the DTO that you're working with and all of the appropriate repo methods. So let me run that. And if I log in, and I go to invoice term setup, now you can see I didn't have any, but it seeded the data, so it created these three terms. I could add another type. I could say like net 120, and there we go. So I have that. I can delete the ones I don't want to use, assuming they're not referred to by any other invoices, and since we don't have any invoices yet, that's not a problem. But as soon as I delete all of them, it's going to reseed the three default values again. So the user is never going to be able to have nothing. It's just they're going to have these default values. So this works exactly like customer setup. And I guess, eliminated the menu up here where it says customers. Now it doesn't say invoice terms. So that's got to be up here somewhere. Yeah, it would have been up here in the customers. So I can put that up here too. And just call it invoice terms. Now my notes I had before included this authorized view and authorized. You can put this around anything you want to make sure is only visible when the user's logged in. Now, the whole page wasn't allowing this component to even render unless the user was logged in. But it can't hurt actually to stick this around the data grid anyway, because it won't show it if they're not logged in if you do that. So that's what the authorized view can do anytime you want. So I could even add that back to the customer setup component, but for now I can just leave it out. But for consistency, I'll put it in. So let me go over here, and in front of customers, I'll add that, and after it, I'll put that as well. So now we just know none of this is going to show if they're not logged in. Now let's work with the home page, because the home page is actually going to list all the invoices the user has and allow them to add new ones. So if I go to the index page, we have our little test that we did that showed customers, etc. Welcome to your new app. I'm just going to change this to be invoices. And I'm going to delete all of this because we're not going to be doing this little test, and I'm not going to be doing any of this either. So I've changed the home page to be a very basic home page. We're going to include a invoices component. So let's add that. And that's good. So but let me go back to the actual index page. And similar to the customer setup and index term setup page, we need a authorized view to show the actual component if they're logged in, or a message if they're not logged in. So let me put that over here, and this will just be invoices. If they're authorized, I will show the invoice component. If they're not, I will say please log in to see your invoices. So this is the default page, so this is the first thing you're going to see when it pops up. Now our invoice component doesn't do anything yet, but it's going to be largely similar, it's another data grid, to the customers and invoice term setup, but it's going to have a little more to it because there's more columns in an invoice. So I'm going to paste this in. And then we're going to work with it. So let me explain what's going on with this, because it's very similar. It's not much different than the other. It's a data grid. So we have here the add feature, this button, just like we did in the other pages. We have the grid itself, which is going to be referred to by invoices grid. We're not allowing alternating row style. We're allowing sorting. We're allowing filtering, which I'll show what that does, and that's an automatic feature. Simple filtering. We're allowing insensitive case filtering, so you'll see what that does too. The data is the invoices list, which is a list of invoice DTO objects. We're telling it this grid is mapped to invoice DTO objects, and we have columns. The first column is going to be a column you just view, and it's going to be the invoice number. We can't edit that, so we're going to just let that be displayed. That's a number that's incrementing automatically in the database. The next one is the create date. Again, you can't change the create date because that's set when you create the actual invoice automatically. But you can display it with this formatting. So I'm going to have it format the date using this format. Then there's a description column, which it'll just pull right out of the DTO as well. Now here's the first kind of weird column in this table. It's the customer name. And what this is going to show just the customer name. So, if we had our two customers we made, Microsoft and Tesla. But I want to let the user be able to check off the customers that they want to see. So if it's going to have a little filtering drop-down option. And that's what this filter value and filter operator and logical filter operator do. It's telling me that there's going to be a list of the potential customer names. It's going to say, show me only records that contain the customer names that I check off. And it'll show all of the ones I do because it'll be or. So if I checked off Microsoft and Tesla, it'll show Microsoft and Tesla. So you'll see what this does when I actually run it. And the actual filter template, which is at the top of the column, will show a drop-down box of all of the customers' names. And if they change it, it'll call this function here, which will set which customer names are selected. And it will allow me to pick multiple. So again, this all came from the Radzen data grid documentation on their website. So I won't spend too much time explaining this, but it's good to see it as an example. The next column are the invoice terms. So it's going to be very similar. It's going to allow a filterable drop-down of all the possible invoice terms. And you'll be able to check off, like I want to see the net 60, the net 30s, etc. And it'll only show those. The next column is the invoice total. And that is just a non-editable thing. That's just the total of all of the line items in the invoice, which is calculated. You can't filter it. You can sort it, but you can't filter it. And that's what this filterable false is. How are we displaying it? We're displaying it as a money. So, but it's calculating the invoice total plus the tax. So it's adding the tax to the total to make sure that we get a proper total. And it's formatting using this string format, which will show it as money. The C stands for currency. The next column is how much money is due. So you can see how much is left. And that's another calculated field. It takes the total minus, which it calculated before, but it's the same calculation, minus how much is paid, minus how much credit we've given the user. So we can see how much money is due on their invoices. Now here, this last column, we have a button. And this button lets us click into the details of the invoice because we're not going to edit all of the details of the invoice. I can't show all the line items on this page. We're just showing summaries of the invoice. So this open invoice method is going to happen when we click the button, and that's going to link to another page, which we haven't implemented yet. So we'll get to that. So here, that's what's going to be in this grid. So to make this grid work, we have to load in our invoices, but we actually need to load in all of our customers and invoice terms as well. Why? Because we're providing those in the drop-downs for the filters. So we have to know what all the possible customers are and all the possible invoice terms. And here is the actual data grid that we referenced to. Here's our error message. There's a drop-down value because we have a drop-down box, and it needs to be mapped to a drop-down value, which we set to empty by default. We have an enumerable of strings. This is also part of the drop-down to see what's checked off. All the names that we check off will be in this list based on the functionality of the filter above. And that is going to be implemented using this on selected customer name change. And anytime you change the selected customer names, if there are no selected customer names, then you set it back to null. This all came from an example on Radzen, so if you want more information on that, you can check them out. Now, and then this is exactly the same thing, but it's for the invoice terms drop-down filter. Now, here's our main initialization, which finds out who's logged in, retrieves all of the customers, puts the values in the customer names. This retrieves all the invoice terms and puts all of those in those invoice terms values, again for the filter dropdown. And then this will actually retrieve all of the invoices. And I'm using that getAllMine flat because I'm going to be bringing in the name of the customer and the invoice terms as well. I don't want to have to go get that from the other tables. So that is the flat representation. And then down here, we have open invoice. So at the end of the row, there's going to be a click that the user can do. And if they click it, it's going to take them to another page. So it's going to navigate. This is using the navigation manager, which I injected at the very top. So this is another service that's provided in Blazor called the navigation manager. What it lets you do is redirect the user to another page in your site. So we're currently on the slash page, the home page. If I wanted to go to the customer setup page, I could do navigate to /customer setup. But we're going to take them to this invoice detail page. And actually the URL is going to be the /invoice detail / the ID of the particular invoice we want to look at. So I'll show you how that works when it's finished. So the rest of these are all the functions that we're used to. We're not doing any inline editing in this like we did in the customer setup. They can't make any changes to these invoices. If they want to edit the invoice, they're going to have to go to this invoice detail page. But they do have the ability to add a new invoice, so that's what this is for. So when we click the button to add an invoice, we're going to find out who's logged in. Then we're going to get all of the invoice terms. And we're going to, for a reason, you'll see why. We're going to add an invoice. So we're creating a new invoice DTO from scratch. So this is going to be an invoice that has default settings. It's going to have, the invoice number is not set here, if you notice, because that automatically creates itself from the database. We set that up a way back. However, the description isn't automatic, so we're just going to call it new invoice. The create date is now. There's no credit given, nothing paid, no tax rate by default. The customer ID is going to be whatever customer is currently selected in the dropdown, which is at the very top. And the invoice terms ID is going to be whatever the first terms are. So that's why I actually had to load all the terms here. So I loaded all of the terms and just picked the ID of the first one here. That's what this does. Takes the first term and just picks that ID. So whatever the first one is, it's going to assign that by default. Then we save it. And then as soon as it's saved, we jumped to the page that lets us edit it. So we don't reload the list. We don't reload the thing. We jump right to the new page to edit that particular invoice. So you're going to see how this works. But we're going to have to implement this invoice detail page first before you can see how it works, because it's going to jump there and it's not going to work. So in fact, I'll prove it to you. I'll run the program. And I'll log in. See, now I see that the invoices are supposed to be shown here, but we're not logged in yet. So we see a table. The table has the invoice number column, the create date, a description, customer name, and invoice terms. Here's where we can actually check off the ones we want to see. So if we only want to see Tesla invoices, we can check that off. Or if we only want to see net 30 invoices, we can check that off. If we want to type a description in and search for invoices of that description, it'll work. The create date means we can pick up, this is all built into the Radzen. It's this nice ability to create a date query to filter your data to. But there are no records yet. So if I click Tesla as my dropdown, so this dropdown has my options, and do add new invoice, what it did is it actually created an invoice for Tesla and put it in the database, retrieved the ID that was created, and it sent us here. See, /invoice detail / then this ID. This is the ID of the actual invoice that it created. So this page is going to be able to show those details once we implement it. But it doesn't happen. It doesn't exist yet. So there's nothing at this address because the router doesn't know what that is. So if I go back to home, you'll see, however, there is an invoice in here now. Invoice number 1 with this date, new invoice, Tesla, net 90, 0, and no money due. And it has an edit button, which also takes us back to this address, which doesn't exist yet. So we're on the way to make this work. If I go home, it's there. I can add it. Let me add a Microsoft invoice. It redirects to the detail page, which doesn't exist. But if I go home, I can see there are two. And now I can show you the filters. So if I wanted to only see Microsoft, I check Microsoft, and now it's only showing Microsoft. If I want to do only the net 90s, it shows those. If I want to do net 60s, there's nothing, so it doesn't show those. It even has this nice, there's no records to display. So this component's very powerful. It does a lot of this work for you. So it's good to use components like this instead of trying to implement this from scratch. I can sort by totals. I can sort by customer name, by date, by invoice number. So these sorts do all work. So to wrap this up, we're going to have to create the invoice detail page, which is where I end up when I add an invoice or hit edit. Now the URL is interesting because most of our URLs so far have just been slash something like slash customer setup, slash invoice term setup, just slash nothing. But since this edit details or this invoice detail page is going to be special for each invoice, we have to know which invoice we're dealing with on that page because it'll show the details of that particular invoice. That's why we added to the URL this ID at the end. And this is literally the ID of the invoice. So it's going to be able to grab that ID, and we'll show you how to do that to show just the details of that invoice. So, but what we're going to have to do is we're going to have to add an invoice detail page now. So let's go ahead and do that. So again, that's under pages, and I'm going to add a Razor component, invoice detail. And so this knows where to get. I can do page invoice detail. All right. Now, we have to put another thing in here because remember I told you that there is a ID that follows this. So we give this page a little bit more of a option here at the end. So I do slash, and then I do in curly braces ID. This is going to take whatever is there and put it in a parameter called ID. Now, how do I actually set the parameter? Well, there needs to actually be a matching parameter down here in the code, an actual member of the class that's called ID. So I can add this, and now this ID, which is really the whole thing, slash that ID, will end up being stored in this variable. So now I have the page. I just have to add a component to the page. So let me create a component for invoice detail. Which is actually a component. Let me do that again. Razor component, invoice detail. Component. And we're going to use a parameter on this one, like I showed you as possible earlier. And we're going to do that by back on the page for the invoice detail. I'm going to refer to the invoice detail component like I normally would, and I'd normally just end it like that if I wanted to include it. But what I'm going to do is actually pass in a parameter called ID and pass in the variable ID. Now it doesn't have that parameter yet, so I'm going to actually make that parameter inside of the invoice detail component itself, which is going to be right here. So if I go into invoice detail component, I can put it right there. So that ID will be set. So I've passed the ID from the URL into the page, and then from the page into this component. Now there's going to be a lot going on in this component because it's going to show a lot of things. So let me start. We're going to be using another Radzen component that requires a little bit more setup. We're going to use a dialog box component, which is going to warn us before we try to delete the whole invoice, because we want to allow people to delete invoices, but it's not something you want to do lightly. So I want to pop up something to show them, are you sure you wish to delete this? So we have to kind of wire that up. And this is, again, from the Radzen documentation. But to do it, we first go back to program. And they have a service for this that we have to add. And it's called the dialog service. So if I add that here, it now will be running. The next thing I want to do is go back to the component, and we're going to be injecting a few things here. We're going to be using 4 different services. I'm going to get rid of this top header. So we're going to be injecting our repository again, our authentication state provider again, the navigation manager again, because we want to follow links to other pages, and then this dialog service I mentioned that's going to handle pop-up dialogues. Okay, so at the top of the page, I'm not going to show any data grid at the top. I'm going to just show individual fields from the invoice. So remember, we only have to show one invoice on this page, so I don't need a table to show the invoice. I'll need a table for the line items, but for the invoice itself, I don't. So I'm just going to put a series of divs that are going to be responsible for showing and allowing us to edit the invoice itself. So this is what I have. We have a div that has a label first with the invoice number. And we include the actual invoice's invoice number. So you can see already that's red. There's going to be a property on this class that stores the invoice that we are loading from the database. So let me actually go put that down there too, at the bottom. So the error goes away there. And of course, we're going to load that from the database. So we'll get to that. So, but we're going to show the invoice's invoice number here. In the next row, we're going to show a description label and then a text box that shows the description of the invoice. And it's a text box, so the user could type in a new value in the text box. And if they change it, it's going to call this onChange method, which we're going to write soon. The next one is going to be the customer. So it's going to be a drop-down that's going to show all of the customers. The currently highlighted customer will be bound to the invoice's customer ID. And the total set of all customers will be this customer's list, which we're going to get from the database. And again, if we change it, it'll call onChange. The invoice terms will be another drop-down that will be bound to the current invoice terms ID of the particular invoice we're looking at. But all of the choices in the drop-down are the total terms we'll be getting from the database. And then if it changes, onChange will be called. This date picker object will let us change the create date. It'll be bound to the invoice's create date property. And again, if that changes, it'll call onChange as well. The paid amount is just going to be shown as the paid amount, but it's a numeric, which lets you edit numbers. And that, again, if it changes, we'll call onChange. Credit amount, same thing. It's numbers, so it's a numeric editor. Also will be called onChange if it changes. And then this tax rate is another number, so it'll show the current tax rate, and if it changes, then onChange will be called. So we might as well implement we might as well retrieve the customers and the terms from the database and implement onChange. So let's define the customers and terms first down here. And then let's actually load them up when the page is loaded. So again, that's the onInitialized async. Okay, so the first thing we do is find out who's logged in, because we need to load all of our customers for that dropdown, all of the terms for the dropdown, and the actual invoice that we're dealing with. Now we're also going to load in all the line items for this invoice. So I'm going to go ahead and have another list of invoice line items. So because our invoices have line items, so we might as well load those as well. So all of this data is going to be loaded when we first hit the page. Notice we did get mine by ID, and we do get all by invoice ID. It's just pulling that ID right from the URL. So that parameter that came in, which was the URL, it's going to use that to know what invoice to load. And of course, it's going to have to match that it actually is our invoice, so it's going to check the user ID as well for security. Okay. So that's that. So now we need to be able to change. So we have on change. And we're also going to need a button to save the changes. So at the end of this whole list of things, I have a button here called Save. And it's going to allow the user to click Save Changes if they made any changes to these values up here. So we're going to have to implement on Save Changes as well. And Save Disabled. So if we ever want to disable the Save Change button, which we may want to do at any given time, we change the value of Save Disabled, which we haven't created yet. So I'm going to go ahead and create that as well. And that is going to be by default false. It's actually going to be, or true. It's actually going to be disabled by default because it's not going to let you save any changes unless you make any changes. Now, how do we know if we make any changes? Well, that's where onChange comes in. OnChange is actually very simple. It will change Save Disabled to false to allow us to click the Save button if any of these things change. So that's why I linked the change attribute on all of these things to onChange. So if we change the description, or we pick a different customer from the dropdown, or we change one of these numbers, it will enable the Save button. Now what happens when we actually click the Save button? So that's going to be on Save Changes. So what I'm going to do there is implement that as well. Not complicated at all. All it does is find out who's logged in and then update my invoice with the invoice DTO. Why does this work? These up here, notice it says bind value. This is a text box. The value of this invoice.description is bound bidirectionally. If you change the description in this text box, it will actually change the value in the invoice object. So we don't have to do anything down here when we save changes except just pass this invoice back into our update, because all of these properties on invoice will have been updated based on, like, if they retype the description, that'll be changed. If they change the create date, that'll be changed. And then we just go ahead and save it. So this allows us to make some changes to our invoice. So we can go ahead and actually do this. Let me run it. And I'll log in because I can't see any invoices unless I log in. And if I go over here to edit this first invoice here, you can see I have the invoice number, the description of the invoice, the customer, the terms, and all these other things. So I could change this to be like Microsoft invoice 1. Now, as soon as I click off of there, it knows it changed. So my Save Changes button is enabled. I can change this. I'll leave it at Microsoft, but I'll change the terms to 30. I can change the create date to, let's say, the 13th. And I'll give them a credit of, let's say, $200. And we'll say it's a 5% tax. So if I save changes, it grayed out, but it worked. If I go back to home, you'll see that now it's showing Microsoft Invoice 1. So, and it's net 30. So the changes I made here were represented on the home page and in the database. Now we're not done with this page because this is showing the general stats or general settings for the invoice, but it's not showing us the line items. So we need to create a grid for the line items down here. So I'm going to introduce the rest of the variables we're going to need. We're going to need these additional variables. So just similar to what we did before for the customers and the invoice terms grids, we're going to allow editing. So we need to have a line item to insert, a line item to update. We're also going to keep track of some totals. We're going to keep track at the bottom of running totals of how much this invoice is worth. And we're going to have another error message. So where do I put that? There's a location for that somewhere here on the page. I could put it at the very top like I did on the customer setup component. So I'll just copy that, put it right there at the top. Okay, so let's go up here to the HTML, and right below this button, we're going to start the data grid for the list items. So here are the line items. Let me copy this whole table in all the way down to the bottom. All right. So we have a couple things missing. We were calling this the line items grid, so I need to make the object down there for that as well, which is a Radzen data grid of invoice line item DTO objects. And that will be set to that. Okay. It's going to be similar to our other tables that we've done. So it's going to have a row update, an on create, a reset, an insert row. This is another button above, which again has this disabled option. This is all the same as the other customers. However, it doesn't just have one editable field. It's got multiple editable fields. So the columns here, there's more than one column. There's a column for the description, which in edit mode has a text box with a required validator. Then the next thing is a price, unit price, which in edit mode is going to have the numeric editor. The next thing is a quantity, which in edit mode is going to have another numeric editor. And notice there's a validator too. Must have a quantity greater than or equal to 0. So that's a range validator. Then there's going to be a total column, which is calculated. So there's no editing there. It's just the template, not the edit template. It'll format the unit price times the quantity and always show an up-to-date total price based on these two variables. Then we're going to have our buttons. So similar to we had on the other data lists, our data grids, we had buttons for editing, deleting, editing, saving, canceling, etc. So let me go and insert those functions. All right, so let's do on save changes first. Wait, we have save changes. Sorry, that's from above. Okay. We're going to have our reset like we did before, which resets our message and those two variables. We're going to have a delete option, which we're going to deal with later, actually. Let's do edit row. Edit row will edit that line item, which will tell the grid to commence editing on that row. On update row will actually occur when we're done updating a row. I'm going to introduce this update totals. You'll see that in a second. So we'll leave that red for now. But it will update the row for the line item, and then update all the totals, because we're going to display a total at the bottom. And if we've changed a row, it could possibly change the total. So we have a function called update totals we're going to do. Save the row is if they say they want to save it. So this marks it for saving. On update row again, though, it actually does the saving. So it actually calls the repository and changes the database. Cancel edit is if they click that they want to stop editing that row. Delete row is if they want to delete one of the rows, and that has a little more logic to it. We have to find out who's logged in. We do reset those variables. Look for that line item. If it's found, delete it, reload the grid. Else, just cancel editing. And if it doesn't let us delete because it's being used by an invoice, it'll catch it and tell us. And then, of course, if you delete a line item, that'll also update the total value of the invoice. So we're going to call this update totals again. Insert row will just insert a new row into the grid, which when saved, we'll call on create row, which will actually go and add the row to the database and reload the grid with all of the new updated line items. And again, update the totals. So what is this update totals that we see here that's happening? Let's go here and grab update totals. All this is a function that will actually literally calculate the total for the invoice. So what it does is it sets it to 0, goes through all of the line items, and adds to the total all of the unit prices and quantities. And that's this variable, which, by the way, we show up here. We show it on the screen here in this thing. We format the string of invoice total. Then we also calculate the tax, which is also shown, calculate the total with tax, which is also shown, and then the amount due, which is also shown above. So this just updates all of these things at the bottom of the page that show us what's going on. Now the last thing we need to do is delete. So delete invoice is going to pop up a message to ask the user if they want to delete it before it actually deletes it. So let me introduce that code by going down here, really put it anywhere. So what this does is it's, again, who's logged in. This dialog service, which I injected, has an option for confirm. This will automatically pop up a dialog that asks the question, are you sure? And its title will be remove invoice. There'll be a yes and a no choice. If the result is true, that means they said yes, which means we will call a repository to delete with line items. So that was that special method we made that would clear the whole invoice out, save the database, and then, since we've removed it, we navigate away from the detail page because we can't see details for an invoice that does not exist anymore. So that goes back to the list of invoices, and we should see the invoice no longer there. So the update totals is also needs to be called when we initialize, because after we first load this page, we need to calculate the initial totals for the bottom of the page based on these line items. So that has to be there. Okay, let's run this. Let's log in. Okay, so we have a couple invoices. Let's go to the detail page on here. So again, we have our top section we can edit, but now we have our line items. And you can see there are no line items yet. So if I click add, it's going to add a row. I'm going to call this, let's say computer. And it's a $1,200 computer, and there's one of them. Notice this total column automatically calculates based on multiplying 1 and 1,200. If I hit check, it saves it and stops editing the row. And remember, we called update totals. So down here, it changed the total to this, the tax to this. You know, there's no tax. So I could change that. If I go here and make the tax rate 5% and do save changes, it changed it, but notice it didn't update the total. So I have to call update totals in save changes, which I forgot to do. So let's go to save changes and then do update totals. So let's try that again. Let's go to log in again. Edit this invoice, and okay, there's the tax shown now, but what if I change it to 10%? Save it. There, it changed. So that's working. Now I can keep adding new line items, and I'll put in like USB drives or something, and they're $10 each, and we have 30 of them. So that adds to the total. I can say they've already paid $1,000, which means they now owe $650. So this is all working good. I'm going to leave this invoice intact because it's a good invoice. So if I go back home, I'm going to go delete this first one. So if I go into edit and I go down here, I can do delete invoice. Now the dialog didn't pop up, so we're missing something with the dialog service. What we're missing is we actually have to add the Radzen dialog component somewhere. Now where do we want to add it? It has to be on the page that we need it, but we could add it somewhere that's on every page. So this layout is every page. So if I go here and close this, I could actually go to my main layout and stick it here really anywhere I like. I can just stick it here maybe after the body. So the Radzen dialog will be on every single page. So let me try that again. Now normally you don't see it, so it's a component that's not visible unless it's activated. So it's sitting there on every page. If I log in and go to this first invoice, and now I click delete invoice, now it pops up. So, and you actually notice it's centered here in this area because I made it part of that portion of the layout. So you could move it if you wanted to. But if I hit no, then nothing happens. It doesn't delete the invoice. But if I hit this and then hit yes, invoice is gone and it redirects me back home. So we now have the ability to bounce back and forth into editing the invoice itself, deleting it, adding line items, deleting line items, and manipulating this invoice. In this video, I'm going to explain how to add unit tests to your project. The first thing you need to do is create an actual unit test project. That will be another part of your solution. So we go over to solution here, and we right click and do add new project. And we're going to start with the XUnit test project in C#. I'm going to call this Blazor Invoice App Tests. What that does is it creates another project that lives alongside your Blazor Invoice App project in the same solution. Now we're going to be taking advantage of the bUnit test library, which is an extension of XUnit that works with Blazor. So if we go to Tools and go to the NuGet Package Manager, we're going to search for bUnit. And we're going to include that in our tests project. And since we're going to be testing database as well, I want to include the mock database library. So I'll install that as well. Now to get the project actually completed, I have to add a dependency from this project back to my actual Blazor project so we can load in the components from that project. So let me right click also and do add project reference, and I'll check off Blazor Invoice App. Now the way XUnit works is you create methods inside of classes in the project, and you put a fact attribute on each method that is considered an actual test, so that when you run test up here, it's going to run all those methods. So I'm going to put in a test class that I've developed for testing the customers component. And remember, that's the component that lets you add, remove, and update customers. So let me go ahead and create a class for that. So I'm going to right click and add a class called setup customers component test. And let me paste the code in for that. Okay, the first thing I want to mention is that these tests are an extension of the test context object. This is a bUnit object. So this includes additional testing functionality that'll let us create a mock Blazor environment that we'll be able to host components in and test against them. So in the constructor, I refer to a setup environment method. So let's take a look at that. What I need to do is I need to create a mock environment. So in order to do that, I have to create a few scenarios. I have to have a user that's logged in, and I also have to have a mock database. So I'm going to scroll down and show you the mock database first so you can get an idea of what that looks like. It's all the way at the bottom. And there's a method called initData, which I will call back up there in the method I was just looking at. But what it does is it creates, using an application DB context, or that's passed in, which you'll see above. If it's not null, what I do is I clear out this mock database. So it's going to be a temporary copy of the database just to run the tests. Clear it out, and then I run migrate, which will actually create all the appropriate tables from the migrations in the other project, and save the changes. So at this point, all the tables are created. Now what I do is I create data for the tables. So the identity user, which matches to the ASP.NET users table, I create a user ID with a fixed global unique ID, passwords, etc. All of this data I got from a run that I did of the other project and just copied the data into here. So this creates an identity user, and I obviously add it to the data contexts, users, property, and add collection. And then I'm going to go ahead and create 3 customers. So I create 3 customers with 3 unique IDs and the user ID from above. So we know that it's owned by that user. And this is the user we're going to simulate being logged in. So notice you'll see that this user ID with the 53DE GUID, you'll see again. Add those 3 customers and save the changes. So this, since we're only testing customer functionality, my mock database only needs to have a user with 3 customers at this point. So if I go back up to the init setup environment function, you'll see what I do is to simulate a logged in user. First, I create the claims of a simulated login user. So that's what this is. It's an array of claims, and the only one we ever look at in our code is this long one that I mentioned that has the user ID in it. So I physically set this to the user ID of the mock data that I just showed you. Then I create an authentication context using this username and the claims I created above. So we get the user ID in there. Then I set up the other things that are required to run my components. So we need the things that we needed back in the other Blazor component, or Blazor application, in the program.cs. So I have this JS interop option. I have, which is just a Radzen thing. It's nothing fancy. And then we have the Automapper profile, and mapper service that we add. Then the Radzen dialog service. Then we add a mock DB context factory using the mock library. So this is slightly different, but it mocks the same exact database using SQL Server as well. So all of the same things that could go wrong in a SQL Server will go wrong in this local copy of the SQL Server for the most part. And we make it a testDB file instead of the file that is for our actual application. So all this data is isolated. This data will just be for testing. And there we call the init data that I talked about before. Now let's take a look at some of the tests themselves. So this first test, every test in XUnit is labeled a fact. So what this will do is it'll run. When you run your tests, it'll discover everything that has a fact attribute on it and run them. So the first thing this test is going to do, and it's going to simulate adding a new customer. That's what the point of this test is. So there's this cut object that we create by rendering our component. So we render the customer setup component, which includes its user interface and everything. And what we do is, since we render a component, it could take some time to render and produce the data grid with the list of test customers. So the first test we do is a wait. So we wait for the fact that it can find the test customer 1 span with this title. This is HTML it's looking for. When it sees this HTML, it knows that the data grid loaded successfully. And once we know that it's done loading, which is because it can see one of these results, we then go ahead and look for the other 2 results because they should be there as well. We don't need to wait again because we waited once for the first one. So they should all be there at this point, and we look for customer 2 and 3. So if any of these fail, the entire test will fail, and it'll be marked as a failed test. Now the first thing we do is we look for the first button and click it. Now that is the button that is the button at the first button on the page, which is the add button. Then we look for the buttons again, and we which we're going to click down here, but let me say what we do first. We actually look for the input as well. So again, thank you for watching this video course. I hope you found it useful. I'm looking forward to doing another version of this when .NET 8 is released. So please like and subscribe so you'll be notified when that comes out.